Hello and welcome. You must have gone through the classic Azure ML Studio by now, as well as the Python crash course that I have created for you. The Classic Studio is pretty easy to work with. It's a very simple drag and drop tool. But it has certain limitations, and the coding, particularly in Python, provides lots of flexibility in doing certain tasks. Now in this section, let me introduce Pandas, which is one of the most powerful packages for data processing. So you have seen the import data module, adding columns, rows, cleaning the missing data, and many other Azure ML Studio modules. And now, when we are working with Python, we can achieve all of these data processing steps using Pandas. So let's go ahead and learn this in the context of the Azure ML Studio. And because you have already learned the Studio, I'm going to compare these data processing modules with Python functions. That way, it will be very easy for you to understand it. So let's go ahead and see how to use Pandas. Now, majority of the time, you will see Pandas installed on your machine when you are using some development tool such as Spyder or PyCharm. And you can simply import it as import pandas as pd. Select and execute it, and as it goes well, we can then start using various functions of Pandas for data processing. So in the next lecture, let's see how to get the data for our experiment. Some exciting stuff is waiting for you, so see you soon and do not go away. Thank you so much for watching. Hello and welcome. During the Studio hands-on, we saw that we can get the data for our experiment by either uploading the dataset or by using the import data. Typically, we upload the comma-separated or CSV or TSV files. We have also seen how we can import the data stored at a particular HTTP location. Even Pandas support a huge set of data sources. And as you can see, you can read a delimited file, which can be either a CSV, TSV, or any other flat file with some delimiter. Then we can also read an Excel file, a JSON format file, as well as the data stored at some URL using the read_HTML function. Pandas can also read data from the HDF store, Parquet, SAS files, as well as the SQL tables. So let's go back to the Python environment and see how we can read the CSV files to begin with. So here I am, and I'm going to use the same lone file that we used earlier. I have kept the files in the data folder under my working directory, and let's now read it using Pandas. So all we need to do is type a variable name in which we are going to collect the data as df, and I will explain why I'm naming this as df very soon, equals to pd, which will refer to the pandas package as we have specified import pandas as pd. Dot, and the function to read the CSV is read_CSV followed by two parentheses. And now inside these parentheses, we can specify the CSV file name as within quotes, the relative path of the file, of course. So relative here simply means the relative to the working directory in which this program is running. And that can be provided by specifying a dot followed by slash data slash and then the file name as lone space data dot CSV. That's it. Now, this is the simplest possible way in which we can read the CSV file. There are various other parameters that we can specify for this function. But for now, let's see with just the file name. So simply select all the lines and hit Ctrl+Enter or F9 to execute these lines. It shouldn't take much time and should be done in a flash or a few seconds depending upon your configuration. And once it is done, you will see this variable df with the data type as data frame in the variable explorer, which is simply great because it means the CSV file has been read. But now the question is, what is this type called data frame? Let me open it and then it will be absolutely clear. I'm just going to expand it to the full screen, and as you can see, the entire CSV file is now available as a table. So we have this index that starts with 0 and is incremented by 1. Then the first record of this lone data file has been taken by default as the headers for this data frame, or we can say these are the column names. So in a sense, the data frame is nothing but the tabular representation of our structured data with columns and rows. It is very similar to Excel or Google Sheets that you may be familiar with. And now that we have it in this table form, we can perform various operations on these columns and rows. So first, let me close this and let's see some parameters of this read_CSV function of Pandas. Now, as you must have noticed, I also have this lone data tab.txt file. Now, this is also a delimited file, but instead of using a comma as delimiter, we have the tab as the delimiter. So let's code for this file now. So let me first copy and paste this read_CSV statement. And now let me change the name of the file to lone data tab.txt. All right. And also change the variable name to df_tab. Now, for the earlier case, we had the comma as a column separator, but now in this file, we have the tab as the column separator. So we need to mention that as a parameter explicitly. So a comma after this file name, and then the parameter for mentioning the column separator is known as SEP, and it will now be equal to tab. So we specify that in quotes as \t, and \t means the tab in Python. So now select and execute this line, and you will now see a new data frame of df_tab created over here. And if you compare these two files of df and df_tab, you will see that they are same data frames despite the fact that one is created from a CSV file and the other from a tab delimited file. And that is correct also because just the separator was different. The data was actually same. Alright, great. So in this lecture, we learned how to load the data into a pandas data frame using read_CSV function. And now let's see a couple of parameters and how to load the data stored at a web URL in the next lecture. Thanks for watching. Welcome back, and now let me show you how we can retrieve the data stored at an URL as well as how to provide the column names to the data frame. Now, if you remember, when we learned the import data module, we used the adult income dataset of UCI library. This was also a comma-separated file, but stored at a URL, or you can say at a remote web location. So let me simply copy this URL for now, and then go back to Spider. And now let me declare another data frame as df_h equals to pd.read_CSV. And now inside the brackets, inside the quotes, I'm going to provide the URL that we copied. So simply paste it inside the quotes. Okay. But in case the actual file name of adult.data, if that doesn't get copied, then just provide that also as adult.data. And now select this line and execute it. Now this dataset is pretty large with more than 32,000 records, and also it is stored at a web location. So depending upon your internet speed, it may take some time. So give it a few seconds and hopefully it should be done. For me, it has finished running, and let me now open it. And there you go. But if you notice it, we have a small problem here. Our column names are weird. We should ideally have the age, working class, education, and so on. But this appears to be just the data. In fact, these columns are nothing but the first record of the data. And that happened because by default, the read_CSV function expects the first row as the header row. So let me close this and let's override the default header parameter. So come to the end of this line and give a comma, and in the next line type header equals to none. Of course with a capital N, because then it becomes a keyword and not the variable. Now this parameter is very similar to that checkbox in the Studio that says CSV has a header. Alright, I hope you can correlate with the Studio as well. So now when you run this line and open the data frame, you will now see that this data frame has just the column numbers and has not selected the first row as the default header, which is correct. But then you may wonder, how do we add those column names to this data frame? Well, it is not that difficult either. All we need to do is create a list of column names and then specify them while reading the data. So to save some time, I simply paused the video and created this list of 15 column names. I just used the short names of the columns for this adult income dataset. And now all we need to do is specify a parameter inside this read_CSV function. So that will be a comma after the header parameter, and on the next line, names equals to, and this list of columns. That's it. Now select the list as well as this read CSV and execute them. It has gone well, and now when you open this data frame of df_h, you will see that it has the same column names as we specified. Great. So I hope now you understand how to import the data as well as how to load the data in a pandas data frame. And as you can see, it is not that difficult either. Now in the next few lectures, let's see few more data processing functions which are very similar or which are almost same as we did in Studio. As always, thank you so much for watching. Welcome back. And now that we have loaded the data from CSV or any such file into the data frame, let's see how we can select a portion of this data frame, or what we know as the Select Columns module from the Azure ML Studio. Now, do you remember the Select Columns module? We used to click on this link here, and then in the dialog box, we would add the columns one by one, and then the output dataset will have just those columns. Here we are doing exactly same, and it is pretty simple using pandas as well. So first, I'm going to collect the output in a variable as df_selected equals to, and let's say we want to select just the age and income columns from this adult income dataset or this df_h data frame. So then we simply provide this data frame of df_h followed by 2 square brackets, and then inside this we need to provide a list of column names that we want to select, and list means another square bracket, and inside that let's provide the column names within the quotes as age, comma, and then let's select the last column of income, so income in quotes again. That's it. And let me now select this line and execute it. It shouldn't take much time and should be done in a flash because the records and the data is in the memory. And let me now open the df selected from the variable explorer. And you will see just these columns as part of this data frame. And you can now use them if there is some column specific processing that you want to do. Great. Now another way of selecting columns is by using its index location, or also known as the iloc. So first let me declare a variable as df underscore iloc equals to, and let's now use the data frame of df followed by a dot again, and then the method of iloc followed by 2 square brackets. And inside these square brackets we can then specify the row and column indices. So let me first open this df data frame and also move it to the side so that we can type while viewing the data. Now first range that we need to specify for iloc is the row range. So let's say we want to select the first 5 rows, and because the index here starts at 0, this is what we will specify as the starting index, followed by a colon, and then we need to mention the end index of the row that we want plus the 1. So basically, if we want the first 5 rows, which means the index starting from 0 until 4, in that case we need to specify 4 plus 1, that is 5 over here. So it works on the same principle that we saw earlier. Alright, and now select this line and execute it. It shouldn't take much time, and once it is done executing it, simply open the df underscore iloc from the variable explorer. And as you can see, we have all the columns as the original data frame, but we only have the rows starting from index 0 until 4. So in this manner, we can select a subset of rows from the data frame. Majority of the time, we would select all the rows unless we are doing some small test on the data. But our aim in this lecture is to understand how to select the rows and columns of a data frame. So let me close this df underscore iloc and keep the df data frame open. Now, if you remember, when we didn't add these columns to this df underscore h data frame with header set to none, the columns were also starting from 0 until whatever is the number of columns. So basically, column index also starts with 0 in case of a data frame. And if I want to select, let's say, just the gender, married, and the dependent columns from this data frame, then we may need to specify their column indices. So in these square brackets, add a comma after this 5, and now the column gender is the second column. That means the index of 1. So specify that, a colon, and now the end index plus 1. So in our case, the dependent column is the 4th column, which means the index of 3, and that's why we specify 3 plus 1 as 4 over here. And now select this line and execute it. There you go, the df underscore iloc now has 5 rows and 3 columns. And open it to see the exact data. And you will see these first 5 rows and the columns of gender, married, and dependents over here. Now, this is pretty generic, and you can always play around with various index values or by specifying some, not specifying the others, and so on. But there is a problem with iloc. Now, if you're interested in random columns from a data frame, I suggest you always go by the column names like this. That way, it is not much prone to the errors. But for larger datasets with hundreds of columns, it may not be feasible to specify the column names. There, you can use the index range for the column selection and the iloc method. Now, one last thing I want to show is the negative index range as well as the drop function for dropping the columns. And in the interest of time, let's do that in the next lecture. Thanks for watching. Welcome back. So let's first see how we can select columns using the negative index. So let me first open the df data frame. And when we say -1 or index as -1, we refer to the last column of the data frame. So for a positive index, index of 0 means the first column of loan ID, whereas the index of -1 means the last column of loan status in this dataset. And then you can travel backward as -2 for property area, -3 for credit history, and so on. Now, in almost all the cases, the last column is the predicted column, or what we call as the dependent or Y column. And all the other columns are independent or X columns. So unless we do some other data processing of removing dummies that we will see later on, the Y column will remain as the last one. So let's see how we can create the X and Y data frames from this loan df using the negative index. So first, I'm going to create the X data frame as X equals to df dot iloc and in square brackets a colon followed by a comma. Now this will mean all the rows from this df. Alright, and then we can ignore the first column index and directly specify the colon. And this will simply mean start from the first column. And then specify the end index as -1. Now, we always select the rows or columns with 1 less than the end position. So when we specified -1 over here, we simply mean we will choose all the columns up to -1, -1, which is up to -2. So the last column will automatically be not selected. And now, before we execute this, let me also code for y variable as y equals to df dot ilog, a colon followed by a comma, and now I'm going to specify the starting index for the column as -1, a colon, and then leave the end position as blank. Now this means we will select all the columns starting from the last column, which is just the last column. Alright, and now let me first select and execute these lines and show the data frame, and then things will be a bit more clear, just in case some of you may still have some doubt. It went well, and as you can see, the df has 13 columns, but the x now has one less and y has just one column. Open them one by one. And there you go, the y data frame now has just the lone status, whereas the x has all the independent features or the independent columns. This is also one of the most commonly used ways of creating the x and y datasets for machine learning experiments in Python. Great. And I hope that explains how we can slice the data using columns as well as the rows using pandas index locations in Python. Let me show you just one more function of pandas before we end this lecture and also end the column selection. In many situations, it is possible that you may have 20-25 columns or even hundreds of columns, and you only want to ignore some 3-4 columns out of them. And those columns could be placed anywhere in the dataset. And that makes it difficult to remove them easily. Now, if we use column selection, there are too many of them. And if you use indexing, that could be prone to errors and may need multiple steps. Then, the easiest method in such cases will be to simply drop them. So let's see how to do that using pandas. And let me now open the df data frame. And let's say we want to drop this first column of lone ID as well as the column of gender, because it is not going to have an impact on the predictions. So then all we need to do, and let me define a new data frame for that as df underscore d equals to df dot drop, and inside the normal parenthesis, then first provide the list of columns to drop. So a square bracket first followed by the column names in quotes as lone underscore ID, a comma, and in another quotes, gender. Alright, and then we need to specify another parameter as axis equals to 1. Now, this axis parameter takes two values of 0 and 1. So when we specify 0, which is also the default value, it will perform the action on rows. And when we specify the axis as 1, the action will be on columns. So let me select these lines and execute it. It should go fine, and you will see that df underscore d now has 2 columns lesser than the df, because these two are dropped. So let me open it. And there you go. We now have the df underscore d starting from married, dependent, and so on. Great. So now we know how to use the negative index while selecting or dropping the last one or last few columns, as well as the drop function for dropping some columns not in a sequence. Now, this was all about slicing or cutting the data or selecting the columns. In the next couple of lectures, let's see how we can add the columns and rows to the existing data frames, the way we used to do that in Azure ML Studio. As always, it's a pleasure to teach you. Thanks for watching. Hello and welcome. Today we will see how to add the columns and rows using pandas. Earlier, we did that using the add column modules and add rows modules in the Azure ML Studio. So let's go to the Python environment and do that with pandas. So here I am, and I have already coded these lines of importing pandas as well as for reading the employee AC1 and employee AC2 datasets. They are pretty similar to the dataset that we used earlier, so I'm not going to explain them again over here. And now, let me select and execute these lines first. And these are small datasets and should be done running quickly. So let me now open df1 for AC1 and df2 for AC2. So the df1 has these columns of name, age, gender, and monthly income, whereas the df2 has years of experience and salary hike as the other two columns. And let's now merge them or create a new data frame, which will have these 4 plus 2, that is 6 columns. So let me create a new data frame as df underscore AC, AC for add columns, equals to, and now we are going to first include the df1 as df1 dot, and then join the df2 to it using a method called join. And inside the parenthesis, provide the second data frame of df2. I think this is pretty easy to understand. And if not, let me execute it. And now you will see the df underscore AC created over here with the same number of rows as df1 and df2, but with 6 columns, which sounds great. So let me open it. And there you go. We now have the columns from df2 added to the df1 and then stored as the third data frame of df-AC. Great. And now if you want to select only certain columns from df2, you can do that as well. All you need to do is provide the column names in a list after df2 in 2 square brackets, which is very similar to what we did in the earlier lecture of column selection. Alright? And now let's see how we can add the rows from one data frame to another. So let me copy these first 3 lines and paste them in a new Python file. And now change the file name to AR1 and AR2 which are also the same ones we used earlier in Studio. And just to make sure we have not made any mistake, I'm going to run these lines. It went well, and now let's add the rows. So I'm going to create a new data frame called df_ar, where the new data set will be stored, and that is equal to, and now we need to use a pandas function called concat for concatenation. So that will be pd.concat, and inside the parenthesis, we need to provide the list of data frames that we want to concatenate. So a square bracket, and inside that, first the df1, then comma and df2. That's it. And it's not 100% accurate, but let me first select and run this line and then show you the problem that gets created when we run it like this. It won't give you any error though. So we have this dfar created with 25 rows. So 8 from df1 and 17 from df2 were surely added. And the column numbers are also same as the other two. So let me open it now. And on the face of it, everything seems to have gone well. But if you see this index, you will notice that the index numbers start once again from 0 after the first 8 records. Which means it kept the index values from df1 as well as df2 intact. Now, it is possible that you may want to keep them as it is. But if that is not the case, which means if you want to reset it, then we need to add one more parameter to this concat function. So a comma after this list of data frames, and then type ignore_index equals to true. By default, it is false, and that's why it kept the indices from both the data frames. Let me now select and run these lines, and then open the dfar. And there you go. Now the index starts from 0 and ends with 24. Or you can say it reset the index for this new data frame. Great. And with that, we have come to the end of this lecture where we learned the join method for adding or joining the columns and the concat function for adding the rows. I hope you are finding it easier to learn these things after learning them in the studio and now comparing that with the pandas. Once again, thank you so much for joining me here and have a great time. Welcome back. During the Azure ML Studio lecture, we saw how we can use the clean missing data module for replacing the missing values from the dataset. We used various substitutions such as mean for numeric columns, median for alphanumeric, and even replacing the entire row from the dataset if it has any missing value. And now let's do that using pandas. So here I have already imported the pandas and have also read the lone data file in this data frame of df. Now let's first try to find out if there are any missing values in this dataset. For that, we can use a function called as isNull. And just to make it simple and easy to read, I'm going to declare a variable as df_null equals to df.isNull with 2 parentheses. Let me run it and show you the output, and then it will be absolutely clear what this function does. And now let me open the df_null and then df as well. And here you will see only the true and false values in df_null. So what is happening here is this function of isNull is simply asking a question to every cell. Is it null? And then returns the answer in the same location. So wherever there was some meaningful value, it returned false because it is not null. Whereas if you see this row with index 11 in df_null, we see this particular cell has value as true. Now, if you go to df and for the corresponding cell over here, you will see a nan value here, which means there was null or not a number value. Now in pandas, the missing values are represented as nan. That means the cell returned true for this question of is it null. You can expand it to see them clearly, and then you have this another cell with index 16 as null for credit history, and then for index 19. But this is not the correct way of counting them. So let me close this, and now let's see another function that we can apply to get the count of all the null values per column. For now, I'm simply going to declare another variable as df_null2 or df_null2 equals to df.isNull with 2 parentheses followed by a dot and sum with 2 parentheses again. Let me execute this line and then open both the df_null as well as df_null2 so that we understand what's going on here. Great. Now in this df_null2, we see these column names and their missing values over here. So what happened was the isNull function returned this data frame of true and false values. And then when we applied the sum function, it did the sum of all the true values in every column. And that's how we got this df_null2 with all these numbers. So lone ID has 0 missing values, then gender has 13 missing values, married has 3, dependent has 15, and so on. So whenever we want to know the missing values from any dataset, we can simply use the combination of isNull with some method and get the count of them. I hope that is clear. Great. And now let's see how we can deal with the missing values. So let's first see the easy one of replacing all the rows with missing values. So let me declare a variable as df underscore clean1 equals to df dot, and now the method to replace every row with missing values is called as dropNA, followed by two parentheses. That's it. Execute it, and now you will see the df clean1 with 480 rows. So it has actually reduced from 614 to 480. Let me open it. And now if you come down a bit, you will see that the index 11 is not there. And that is because it had a missing value in self-employed column, and that's why it was dropped. You will also see that index 19, 23 and 24 are also dropped. If you want, you can verify it by going further down and checking the other values. Alright, and now when we use the dropNA with its default parameters, it is applied on rows because by default the axis is 0. So in case you want to drop the columns with missing data, all you need to do is add axis equals to 1. Select and execute this line, and you will see the columns are now reduced to 6 because we had missing data in 7 out of these 13 columns. Great, and in the next lecture, let's see some basic replacements such as replacing the missing data by mean, median or mode. Thanks for watching. Welcome back, and now if you remember, whenever we wanted to change the data type of any particular column, we use the edit metadata module. So as you can see, the credit history for the loan data is considered as a numeric feature, but it has only two values, 0 and 1. And that is because someone with a higher credit score was considered as good and below that as bad. So basically the ones and zeros here are good or bad, or we can say they are actually categories. Because of that, we need to convert them into categorical features. So when we applied edit metadata, we would select the credit history in this column selector, provide the current data type, and then choose make categorical. And after execution, we would have the credit history column as categorical. That was pretty easy. So let's now go ahead and see how to do that using pandas and Python. So here I am, and first let's see how to get the data type of all the features of a data frame. For that, all we need to do is type df.dtypes. And dtypes here simply means data types. Select and execute this line, and you will see all the columns listed on the console with their dtypes or data types. Alright, and now, as you can see, we have the applicant income, co-applicant income, loan amount term, as well as the credit history as numeric data types of integer or float. Rest are all objects. So now remember, the Python data type of string or alphanumeric is considered as object by pandas. So nothing much to worry there. And now, let's see how we can change the data type of credit history to categorical instead of the numeric float. For that, let's first type df and inside the square brackets, inside the quotes, credit underscore history equals to, and I'm going to copy and paste this again. I can get very lazy at times. And followed by a dot. And now the method to change the data type is called as type, followed by two parentheses as it's a method. And now inside the quotes, the new data type. So let me add category within quotes. So this sentence simply converts the existing float credit history to a categorical credit history. Alright, so let me select and execute it. It should not face any issue in execution. And when it is done, let's once again execute these dtypes to check the new data type. And there you go. The new data type is now category and not float. Great, and I hope now you understand how we can change the data type of any column of the data frame. I hope you can now relate among the AzureML modules as well as the pandas and other Python functions. As always, thank you so much for watching and have a great time. Hello and welcome. When working with any dataset, as you must have noticed, it is always helpful to get the summary statistics of the data that we are dealing with. For AzureML Studio, we used the summarized data module, and when we visualized its output, we got various summaries such as the record count, missing value count, min, max, quartile, and so on. And now let's see how to do that using pandas and Python. And once you know it, it is pretty simple everywhere. So I'm going to continue from where we left in the previous lecture. So we have the pandas imported, df created, and also the credit history is changed to categorical feature. Now, to get the summary statistics, all we need to do is type df.describe with two parentheses. Select and execute this line. And there you go. We now have the count, mean, standard deviation, minimum value, as well as the quartiles or the percentiles for 25th and 50th percentile, or the median value and the 75th percentile, as well as the maximum value. But the summary statistics here are printed only for the numeric columns, of applicant income, co-applicant income, loan amount, and the loan term. And that is because this method by default includes only the numeric columns. And if we need to include all the columns, we have to provide a parameter inside this parenthesis as include equals to and in quotes all in small caps. Once again, select and execute this line. Wow, now it appears to have selected all the columns, but the problem is it could not print everything on the console. So let's collect the result in a variable as df underscore summary, and that is equal to this entire statement. Select and execute it again. Went well. So let me open the df underscore summary. And now you will see it very clearly with all the columns as well as various statistics as index. We also have these two additional indices of top and fric or the frequency. In simple terms, it is nothing but the mode, the highest occurring value. And in frequency, it also provides the number of occurrences of the mode value. And naturally, you won't see the mode for the numeric columns, and that is why it is nan. Also, we don't see the numeric stats such as mean, standard deviation, and percentiles for the non-numeric ones. There, these ones will have nan values. Great. Now, everything looks great, but if you remember, when we visualize the stats in Azure ML Studio, we used to see various percentiles such as 0.5, 1, 5, 95, 99, and even 99.5 percentiles. Whereas, here in Pandas, we see only 25th, 50th, and 75th percentile. So what should we do? Well, it's not difficult at all. Ideally, anything that is coded here has more flexibility. And same is the case with Pandas and Python as well. So to get different percentiles from this described method, all we need to do is add another parameter. So a comma after the include, and in the next line, percentiles, and it's a plural one, equals to, and provide different values between 0 and 1 as a list. So that will be within the square brackets. Let's give the first one as 0.01, 0.05 as the 5th percentile, 0.1 for the 10th percentile, and let's now jump in the 90s as 0.9 for the 90th percentile, 0.99 for 99th, and finally 0.995 for 99.5 percentile. Great. And I think that is an exhaustive enough list. And now, let's select these lines and hit Ctrl plus Enter or F9 to run it. And then again, open the df summary data frame. And there you go. We can now see the different percentile values for all the numeric columns of applicant income, co-applicant income, loan amount, and the loan term. So as you can see, there are 1% applicants who have income less than 1025. And on the higher side, only 0.5% applicants have income more than 40,000. Now, this information can be very handy while dealing with the outliers. Because as you can see, the mean or the average income is 5403. Then from 95 to 99th percentile, there is a significant jump in the income level. And it may be justified. But this 0.5% of the data, which has more than $40,000 as income, can actually be a problem for our algorithm. And as you know, they are called as outliers in the data. So let's see how to deal with the outliers in Python in the next lecture. In this one, I hope you have now learned how to summarize the data using describe as well as a couple of parameters, or I would rather say a couple of important parameters of this method. As always, it's a pleasure to teach you machine learning. Thank you so much for watching. Welcome back, and today let's see how to clip values or remove outliers using Pandas. Now, if you remember, we used clip values module for Azure ML Studio. There, we used to provide either the peaks, sub-peaks, or both over here. And then we also provided the threshold, which could be a constant or the percentile value of certain columns. Then, if you choose percentile, which is also the most common method of clipping the values, we used to provide the upper and lower percentile thresholds. And then, how do we want to substitute those values? And of course, we can perform this only on the numeric columns. Alright? That goes without saying. And I hope that was enough of the recap. So let's now see how to do this in Python using Pandas. So here we are. And now for replacing the outliers, we have to use a method of the Pandas data frame called as clip. And the way to use it is by typing the data frame name of df.clip with two parentheses. Now this method accepts various parameters, but the most important ones are known as lower and upper. The lower parameter specifies the lower limit below which we will clip the values, and the same goes for upper as well. Let me first code it, execute it, and then things will be absolutely clear. But before that, as we know, we can perform this only on numeric columns. Otherwise, you will surely get an error. And that also means we cannot use it on the entire data frame. We will have to choose the numeric columns. So let's first apply it on the applicant income column. So after this df, let's add two square brackets, and within the quotes, the name of the column as applicant income. Let's also provide the lower and upper values for this clip method. And for now, I'm going to add some constant thresholds for lower and upper. So just for example purpose, I'm going to add the lower limit as 999 followed by a comma and then the upper limit of, let's say, 50,000. So now any income value that is below 999 will be replaced by 999 and any income value that is 50,000 or more will be replaced by 50,000. But this again is going to print it on the console and we may not see all the result. So I'm simply going to assign this statement to another variable as df underscore clip equals to and this entire statement. Alright, and now let me select and run it. It shouldn't take much time and you should see the df underscore clip. Open it and let me also click on this column to sort it. And there you go. We have these indices of 188, 216 and others with income as 999. And just to verify it, let's also check the original values. So I'm going to open the original data from the DF. Again, click on this applicant income column to sort it. And as you can see, the index of 216 had a value of 150. Index of 468 had a value of 210. 188 had a value of 674. And all of these are now replaced or clipped at 999. I hope that explains the lower threshold and how it got clipped. Then if we click again on this applicant income column in DF as well as on df underscore clip, you will see that these three indices of 409, 171 and 333 had their income values above 50,000. And that's why they are now clipped at 50k. Great. Here we use the constant values of 999 and 50,000 to replace the outliers or clip them. But we can also use the percentile to do that. So let's see how we can replace the outliers using percentile in the next lecture. So see you soon in the next one. And as always, thank you so much for watching. Welcome back. And now after clipping the outliers using the constant values of 999 and 50k, let's see a slightly better way of doing that by using the quantiles or percentiles. So first, let me create a copy of this data frame as df underscore ol for outliers equals to df dot copy with two parentheses. Great. And as you know, because we cannot apply the percentiles on alphanumeric columns, we need to select the column names of all the numeric columns. Now, this is slightly different than simply selecting the column names. So first, let me declare a variable as columns equals to df underscore ol dot and the method to select all columns of certain data type is known as select underscore dtypes. Not that difficult at all. And then inside the parentheses, we provide a keyword of include equals to and in quotes number. Now, if we simply execute this, it will create a data frame by the name of the columns. But we are interested in the column names. So as you know, we can simply use the attribute of dot columns. Great. And now let's run a loop over these column names and then get the different percentiles. So for now, let me type the for loop as for column in columns colon and hit enter. And let's get the lower threshold at 1 percentile. Let's also collect it in a variable as lower equals to df underscore ol and within the square bracket specify the column name that has been extracted from this list of columns as column. And now the method to get any percentile for a particular column of the data frame is known as quantile. So let me type a dot quantile and inside the normal parenthesis, this method expects a number between 0 and 1 for the percentile. So for the lower threshold, let me type 0.01 for the first percentile. And this statement will now calculate the first percentile for this column of the data frame. And then store that value in this variable of lower. Alright. And similarly, let me get the upper as well. So simply copy and paste this line. Then change the lower to upper. And instead of 0.01, change it to 0.995 or 99.5 percentile. Alright. So for now, let me just print these values here and then see what we get. So simply print with two parentheses and let's print the column name as column, comma, lower, comma, upper. Alright. And now let's execute these lines starting from df.copy until the end and see what happens. Shouldn't take much time. And there you go. It has printed these numeric column names as well as the lower and upper percentiles of 1 and 99.5 percentiles. So we have 1025 and 39943 for the applicant income, 0 and 19434 for co-applicant income, and so on. Then we also have this credit history at 0 and 1. And ideally, you should convert credit history into category before we do this column selection. But here, it does not affect in this case. So I'm going to leave it like that. Our aim here as part of this lecture is to understand how to clip the values with percentiles. So let's see that. So just after the print, let me use this clip method to remove the outliers. So let me type df underscore ol with 2 square brackets for the column reference, and then column inside them equals to, once again, df underscore ol and column inside the square brackets dot clip, and now provide these two variables or thresholds as lower comma upper inside the parenthesis. Ideally, this is what is required, but if you see this printed value, sometimes it can go many places after the decimal digits. So you can round it off using a function called round. So that will be round before this df underscore ol and put this entire thing inside the parenthesis. Let's also specify the rounding at 2 decimal digits, so a comma and a 2 over here. Now make sure the parentheses are closed properly and the comma is at the right place. And let's also do the same for upper as well. And now select these lines from the copy until the end and run it. It should be done quickly. And let me now open the df underscore ol. And then go to the applicant income column and click on it to sort it. And there you go. All these lower values of applicant income is now capped or clipped at 1025, which was the first percentile for this column. Click on it again and you will see this value of 39943 for these rows. And I'm sure they had the value higher than 39K, and that's why it was clipped at the 99.5th percentile value. If you want, you can verify it. And for that, you can always open the original DF data frame and check the values for these indices. Now check it if you want to, or come along with me to the next lecture. As always, thank you so much for joining me here. Hello and welcome. Earlier, while trying to convert or save the output of one of these modules, we used this convert to CSV module. And then when we download it, we can save it as a CSV file. And now in this lecture, let's see how to do that using pandas. For that, I'm going to replicate the exact same steps but using pandas. So here I am, and I have already imported the pandas library as well as read this loan data CSV file. Then I have also dropped the rows with missing values and created this df underscore clean data frame. And now let's convert this df underscore clean data frame into a CSV file and also save it. So for that, all we need to do is type df underscore clean dot to underscore CSV with 2 parentheses, and this method of to underscore CSV will convert this data frame into a CSV file. But so far, we have not specified the location and the name of the file where we want to store it. So let's specify that inside the parenthesis and inside the quotes as dot slash data slash cleaned loan data dot CSV. Also, let me go to the files, and within that, let me expand the data folder so that you can see that there is no cleaned loan data file. And now let me select all the lines and execute them. And there you go. We now have the cleaned loan data.csv file created over here. So let me open it. And wow, the file is exactly as we expected with all the fields separated by a comma. But, and with that but, I'm sure some of you have sensed that there is some problem here. And indeed there is. Now, if you see this first column, there is no header for it. We have this additional comma at the start, and then it starts with the loan ID. And then even in these values, you see that it has started with 1 and getting incremented all the way up to this value of 613. But the line number here is just 481. And remember, we have 480 records in this df underscore clean. And one header is also there. So 481 makes sense. But then what is this 613? Any guesses? Pause the video and see if you can get it. Well, these are nothing but the index values. Remember, we have 614 records in the original data frame, which means the index will start from 0 and then go all the way up to 613. And we dropped some of these rows when we cleaned it. And that is why you will see these indices of 600 and 601 missing over here. Then we also have 597 missing. And if you check, you will find the same for other indices. Now, if you want to keep the index values, this is perfect for you. But in case we do not want to do that, for example, we may not remove the null values or the rows. We may just replace them with mean and mode. In that case, this index is actually not required. So let's see how we can remove it. So let me close this file for now. And now it is pretty easy to remove the index from the output. We just need to add a parameter after this file name and a comma. So on the next line, index equals to false. And by default, it is true. All right. Select and execute this line. And then once again, open the cleaned loan data file. And there you go. We now have a clean file without the index values. Great. And if you have been doing it along with me, congratulations on learning another method of the pandas data frame. Now, this was about the CSV file. What if we want to write a TSV or a tab separated file, or maybe even pipe separated file? Well, this function of toCSV has a very similar parameter as read underscore CSV. So all we need to do is add another parameter called, and can you guess again what it could be? Well, that's right. It is the SEP for the separator. and this SEP will be equal to, in quotes, \t for tab. Let me also change the name of the file to txt instead of CSV. That's it. Now select and execute this line and you will see that the txt file is created under the data folder. Open it and you will see all the columns separated by tab. Great! So now in this lecture, we learned about how to save the CSV as well as tab separated file from a pandas data frame. We also learned how to ignore the index while writing as well as how to use this separator. And with this separator, you can write this file with any delimiter. Alright, and with that, please allow me to end this lecture here. And as always, thank you so much for joining me here. Hello and welcome. So earlier we saw what is normalization, why we need to do that when two variables are on different scale, and then we also saw different methods of normalization or standardization of the data. We then implemented it using the classic Azure ML Studio by bringing in the normalized data module, choosing one of the transformation methods here, and then selecting the numerical columns. And let's now see how to do that in Python. And here I have imported pandas for reading this default.csv file. Let me execute these lines and then show you the data that we are dealing with. And then open the df data frame from the variable explorer. Now this data is about predicting whether the existing credit card customer will default the payment in the next month or not. And you can view this dataset on the UCI website. I have just taken the subset of this dataset and also modified the column names from x1, x2 and so on to some meaningful names. And I have also truncated the columns and the number of rows. So in our dataset, we have this customer ID, then the credit given is the credit card limit of the customer. Then we have these columns of gender, level of education, marital status, and the age. Now, beyond this, rest of the columns are basically the payment status of whether they paid on time or not. Then we have what was the billing amount for that month as well as the actual amount paid in that month. This we have for 3 months. So the original dataset had for 6 months. I have just truncated it down to 3 months. So total 9 such columns is what we have. And finally, we have the predicted column of whether the customer has defaulted in the next month or not. And we need to build a prediction model for that. So we will go through the predictions later on, but for now, let's focus on normalizing or standardizing these numerical values of credit limit, monthly billing amount, paid amount, and others. For now, let me close this. And now here we are going to see 2 ways of normalizing the data. One is min-max and the second is the using z-score. And we know what they are as well as their formulas. So first, let me create a copy of this data frame as data min-max equals to df dot copy with 2 parentheses. And now we need to import the min-max normalizer or the scalar from another package called scikit-learn. And to import it, we need to type from sklearn, which is the short form for scikit-learn, dot pre-processing as one word, import min-max scalar with both the m's and the s capital because it's a class. Now let me execute these lines and it shouldn't give any problem as I have installed this package on my machine. And in case this is not installed on your machine, you can simply go to the console and type pip install scikit-learn. And if you hit enter, it will download and install the latest packages. All right. And now, before we start working with this class, let me click on it and press Ctrl+I to get the help of it. There you have it. And as you can see, the default parameters are mentioned here along with the formula for it. Now, this is the same formula that we saw earlier, where we take the difference of the x value and the minimum value and then divide it by the range or the difference of max and minimum value. The additional range is here just in case you want your data to be scaled on a different range than the default of 0 and 1. So if you want your data in the range of 0 to 100, you can simply provide this parameter of feature range and this formula will then do the rest. Try it if you want to, but for now I'm going ahead with the default range of 0 and 1, which means the resulting data will be scaled between 0 and 1. So for that, let's first create the scalar object from this class as scalar equals to and this class of min-max scalar with 2 parentheses. Okay, and now as we know, we can apply the normalization only on the numerical columns. So let's get all the numerical columns in a variable as columns equals to and then this data frame of data min-max dot select underscore d types and within the parentheses provide include equals to and in quotes number. We have seen this earlier as well, and this needs to be followed by a dot columns. Great. And next, let's actually transform the columns as data min-max and in square brackets provide this columns where we have all the numeric column names. And this is now equal to the object of scalar dot and the method to transform the data is known as fit underscore transform. And within the parentheses, provide the same data as data, min, max, and columns within the square brackets. That's it. So this method will take this data as input, transform it as per the min-max scalar formula, and then store it in these columns. Okay? So let me select these lines and execute them using Control plus Enter. And it should be done quickly. We don't have too much data here. And then open the data min-max data frame from the Variable Explorer. And there you go. We can see this column of credit given is now scaled. So simply click on that column and you will see the minimum value of 0 for it. Click on it again and maximum is now at 1. So our data is now scaled between 0 and 1 from those values in thousands. You can now scroll towards the right and you will see that age as well as other numerical columns of billing amount, etc. are now on the same scale of 0 and 1. Great, and congratulations on learning how to transform the data using min-max scalar. Then there is another transformation that we discussed earlier, and that was Z transform. So let's see that now. And because the steps are more or less same, I'm going to copy and paste these lines from df.copy until the fit transform. All right, and paste them right after this. And now we need to import another class instead of this min-max scalar. So remove this and type standard scalar with s at both the places capital. And then this object will also be of standard scalar instead of min-max. And let me also change the data frame name and create a new copy as data standard instead of the min-max. And change it in this last line as well. And then inside this fit transform also. And I'm doing this so that you can see the difference in scaling. Otherwise, simply changing the name of the class should have been enough. Great. And now select these lines and execute them. And then open the data standard data frame from the Variable Explorer. And there you go. Click on this credit given column now. And wow, the minimum data is now at minus 1.16 and the max is at 4.09. Remember, this will scale the data based on the standard deviation and the mean. And that's why the values will not be in the same range as 0 and 1. And as you check other columns, they will also be in different range, but more or less scaled down from their usual thousands to -1 to maybe 6 or so. Okay? And that's all we need to know for normalizing or scaling down different columns to the same scale. As I always tell you, it is not that difficult once you understand it. So use this as a template whenever you need to do this in your job as a data scientist. For now, let's move on to the next lecture. Thanks for joining me here. Welcome back. So far, we have seen how to import pandas packages, how to read CSV and TSV file using read CSV function of pandas, and we also saw how to replace the missing values for categorical and numerical variables using fill-NA apart from various other data processing steps. And now in this lecture, let's try to understand few more things, particularly what we call label encoder for categorical variables. We know and have discussed in brief that mathematics is the basis for all machine learning algorithms. Whether we are talking about regression, classification, or any other type of algorithm, they all are based on mathematics. So we may have a formula in the form of y equal to a plus bx or a logarithmic formula for logistic. So such mathematical equations require numbers and cannot deal with the string variables such as categorical variable. So when we are dealing with this data where we have gender, area, and loan status, what should we do? Well, that's where the label encoding comes into the picture. With label encoding, we can get rid of the string type of categorical variable and instead create a series of numbers for them. So basically, we may impute or replace the value male as 0 and female as 1. And similarly, 0 for urban and 1 for semi-urban and so on. Then in the loan status column, the y can be replaced with a 0 and n with a 1. And it is not just restricted to 0 and 1. If you have multiple values such as urban, semi-urban and rural as the third categorical value, we can replace that with value 2 and so on. I hope that is clear about what problem categorical variables create and how we can deal with it. Now, if you are working with Designer or Classic Studio, you will see a module called Convert to Indicator Values, which does exactly that. And now let's go ahead and do it in Python program. Now, many people prefer to do this conversion using the label encoder from sklearn. However, I find it very easy to do it using pandas, and you will see why I say that. So for any column whose values we want to change to numeric 1, 2, 3 and so on, we should first convert them to categorical type. So what I'm doing here is first importing the pandas, reading the defaults.csv and then dropping the column of ID because it is not going to have any impact on the prediction. Then similar to selecting the numeric columns, when we did include as number, I am selecting only the object type over here. So instead of number as include, we have object here. And then this dot column means we are extracting the column names in this variable of columns. We have done this earlier as well, so should not be a problem in understanding. And finally, as we did in the edit metadata lecture, I am changing the data type of these columns to category. And just to make sure everything is done correctly, I'm checking the data type here once again. All right. So let me select and run all of these lines. And you will see the columns of gender, education, and all the others change to category now. Great. And now to do further processing, I'm going to create a copy of the df. And let me call that as a dt equals to df dot copy with 2 parentheses. And first, let me drop all the rows with the missing values as dt equals to dt dot drop na with 2 parentheses once again. And I will explain why I'm dropping these rows a little later. But first, let me explain the attribute called cat_code, which we will use for changing the categorical values into numerical codes. And now, this cat.code is applied on series, or we can say on individual columns. We cannot apply that on the entire data frame. So we cannot use it like dt equals to dt dot cat dot code. If you do that and execute this line, you will get an error that the data frame object has no attribute called cat. So for example, if we want to do it only on gender, we can do it as after this dt a square bracket and gender inside that and in quotes, and then put this gender here as well after this dt. And now if you execute this line, it will go fine. And if you open the dt data frame now, you will see that the gender now has zeros and ones instead of male and female. Alright? But then you may ask how to do it for all the columns of dt. Can you guess what can we do? Well, that's right. We can use a for loop on this columns variable. Okay, so we have all the object type of columns or categorical column names in this variable of columns. So let me delete this particular line with gender in it and create a for loop as for column in columns, a colon, and in the next line type dt and column in square brackets equals to dt and column once again and a dot after the square bracket cat dot codes. That's it. And now select these lines from the copy until the end and execute it. It went well. And now let's open the dt data frame. And there you go. We can now see these columns of gender, education, marital status, and the payment status having indicator or numerical values starting from 0. So for gender, you will only see the zeros and ones because it has just 2 categories of male and female. Then for education, you will see 4 values of 0, 1, 2, and 3. And that's because it had 4 categories of university, graduate, high school, and others. And similarly, if you check other columns, you will find the values replaced in the similar manner. And if you are doing it with me, congratulations on learning another important concept. But this is not the end of encoding. This may work for predicted columns when we have more than 2 classes to predict. But for independent or predictor columns, or features as they may call, label encoding can actually create some other issue. So let's try to understand what that issue is and also learn those new steps, which is also called as hot encoding or dummy variable creation. Let's do that in the next lecture. So see you soon and do not go away. Have fun. Welcome back. So because mathematics is the basis for the machine learning algorithms, we have to change the categorical values into numerical ones, such as zeros and ones. And we successfully did that for the categorical columns. But our job is not over yet. We only do the label encoder or imputing numeric values. Instead of string type of variable, we create another problem. Now, because we converted them to numbers, they will now follow all the properties of numbers and all the possible operations of numbers are possible on them. Now, in mathematics, 3 is greater than 2 and 2 is greater than 1. So essentially, we are saying here that rural is greater than semi-urban and semi-urban is greater than urban, which is not the case. Let me make it a little bit more weird and funny so that it is absolutely clear. We may have the city as the categorical variable, and we may convert these cities of London, New York, and Delhi to 1, 2, and 3. Now, as per mathematics, 1 plus 2 equals to 3. So does that mean London plus New York is equal to Delhi? Or even worse conclusion, if your algorithm or program has some average calculations, such as mean, then it gets even more problematic. The average of 1 and 3 is 2. So does that mean the average of London and Delhi is New York? Well, very weird. So that's why we need to binarize this column so that we only have one value. And that process is called as hot encoding based on the terminology used in the digital circuit design. So all we do is create some dummy columns for every categorical value, such as in this case, we create a column for London, one for New York, and one for Delhi. So wherever London is present in a row, we assign the value of 1 for that column, and all the others we assign a value of 0, as you can see here in the first row. And similarly, for this record, we will have 1 for New York and 0 for London and Delhi. And then 1 for Delhi and rest all zeros for the third record. Alright? And by doing this, we definitely solve the problem of comparing the categorical variables with each other in case of label encoding. So now let's go to the Python environment and transform our data and create some dummy variables. Thanks for watching. So here we are in the Spyder IDE, and once again we are reading the file and dropping the column ID. Great. And we are now ready to create the dummy variables for the categorical columns. So for that, let me type df underscore dummy equals to pd for pandas dot, and then the function to create dummies as get underscore dummies, and in normal parenthesis df. Now this function of get underscore dummies will take an input data set and then create the dummy variables for all of the categorical or the object type of columns. You don't even have to convert them to categorical. Let me execute this using Ctrl+Enter, and it will go well. And before we see the output, let's see the detailed description of get underscore dummies by placing the cursor here and hitting Ctrl+I. Great. Let's open the df underscore dummy now so that we can compare the description with the result. So as you can see, we now have 34 columns. The columns of gender, area, education are no more available. Instead of that, and if you scroll towards the right, we now have 2 columns for gender, 1 for male and 1 for female. Then instead of 1 column for education, we now have 4 columns for education, graduate, high school, others, and university. And the same thing we can see for other columns as well. Alright, and now let's see the description of this function. So it takes some data as input, which was our df data frame, then the prefix. So prefix decides what will be the new column names. Remember, one categorical column will produce more than 1 column after creating the dummy variables. So the male, female, all of those got added as the prefix for those columns. If you want a customized one, you can specify it here. You can also specify columns using this parameter of columns. If you do not specify it, then all the categorical or object type of columns are processed. Another important parameter is drop underscore first. So if we want the first column to be dropped, or for that matter, if we have 4 values in a categorical column and want only 3 of them, we can use the drop underscore first to get that. And this is particularly useful for the dependent variables as well as for removing multicollinearity in case of linear regression. Great. So today we saw an important concept of one-hot encoding or creating dummy variables. To see how these values have been converted, I suggest you open the dataset of df and df underscore dummy and compare them side by side. I'm sure it will be fun to understand which value has gone into which column. But for now, that ends this lecture. And thank you so much for joining me here, and enjoy your time. Have fun. Hello and welcome. And now if you remember the models we built using the Classic Studio, it would typically follow a path where we will read the data, do some data processing of selecting the features or columns, then cleaning the missing data, and so on. And finally, when we are ready to train our algorithm, we would split the data into 2 data sets. The first one will go in training the algorithm, and the second we used to process for testing our algorithm's accuracy. Now, while doing the split, we used to provide these parameters of whether we want to split on rows or columns. Then the fraction or percentage of rows that should go in the train or the first dataset, and the random seed as well. And if it is a classification problem, we would also do a stratified split on the predicted column. I hope you have not forgotten about the stratified split that we learned during the Classic Studio lectures. And now let's see how we can do the same using Python. And here I have already read the file and also created the dummies for them. In this, I'm taking one less, or you can say dropping the first dummy column. So let me first execute these lines and then open the df underscore prep. As you can see, it has got these 27 columns. And if you see this last column, you will notice that we have this column of default next month underscore yes. Because we dropped the first one, we don't see a similar column for no. But actually, it does not make sense to have it here, because this column of yes will have 1 when it was yes, and it will be 0 for no. So it does not make a difference even if we have the second column with exactly opposite values over here. Alright? So let me close this first, and now, before we split the data, let's create the x and y out of this df underscore prep. In case of AzureML, we didn't have to do that. And the major reason was because we could specify the dependent column at the time of training, and the AzureML used to take care of the rest of the things. But here we need to create a separate dataset for the dependent column. So then let me type x equals to df underscore prep dot and let's simply drop our column of yes, which is the predicted column. So that will be drop, and within parentheses specify the list of columns. For now there is only one. So within the square brackets and quotes, let's type default next month underscore yes, and a comma after these square brackets, and then specify that we need to apply this column using axis equals to 1. All right, and then let's also create y equals to, and this time let's simply select the last column as df underscore prep dot ilog, and within the square brackets a colon, comma, and a column starting at -1, colon again, and that's it. Which as we know means select starting from the last, which means only the last column. Great. And if you want, you can execute and see the result as well. But for now, I'm going to go ahead and split the data. For that, we need to use another module from sklearn. So import it as from sklearn dot model underscore selection import train underscore test underscore split. All right. And if you want, you can execute it and get it imported. And now keep the cursor there and hit Ctrl+I to get the information about this module. Now here you will see this arrays parameter, which expects sequence of lists or data frames, which in our case are x and y. Now they need to be of same length, which means the number of rows in both these data frames that we specify here need to be same. We don't have to worry about that. Then the next two parameters are in complement with each other. So they are very similar to the fraction of rows parameter that we specified in AzureML. So we have the test underscore size and the train underscore size. And because there are only two outputs of train and test, we typically make the sum of train and test as 1 or 100%. If you want, you can specify different portions here as long as the sum of it does not go beyond 1. Then random underscore state is the same as the random seed in AzureML, and stratify is exactly same as the stratification column that we used to specify for AzureML. There we used to choose one column from the list of columns, whereas here we will specify the column name or the y in this particular case. Alright, and then it returns the two datasets of train and test. So let's now see how to code it. So let me first code the train test module, and then we will see how to assign them to different data frames. So that will be train underscore test underscore split with two parentheses, and inside that let's provide our two data frames of x, comma, y. Another comma, and let's now specify on the new line train underscore size equals to 0.7, or we can say 70% of the records will go in train and 30% will go in test. Another comma, and then random underscore state equals to some random number of 1, 2, 3, 4, comma again, and now let's specify the stratification column as stratify equals to and the data frame of y. And as I said earlier, I'm sure you know from the lecture on AzureML what this means and what it does. So now each of these x and y will be split into train and test. So let me now collect them just before this module as x underscore train, comma x underscore test, another comma, and now let's do the same for y as y underscore train goes first, then comma, and followed by y underscore test. And they all are equal to the output of this module. So just align everything after this equals to sign. Great, and now we are ready to run this and check the output. So select all the lines and hit Ctrl+Enter to execute them. There you go. So initially we had 1600 records and 16 columns in the df data frame. We then dropped the ID and also created dummies, and that meant our df prep now has same number of rows as 1600, but the number of columns are now 27. This was then split into x and y, with x having 26 out of 27 and y having just one predicted column. And finally, when we split the rows in 70-30 ratio, the x test as well as the y test now has 480 records, which is 30% of 1600, and the train now has 1120 records as 70%. Let me now open the x test and the y test, and you will now see the same index number for all the rows of both these data frames. So whenever we use this split module, it will always store the same index rows in both the tests of x and y, as well as the train datasets. And that is pretty much what is required for our algorithms. And that's why both these x and y need to be of same length. Great. And now that completes this lecture on how to split the data in train and test using Python and sklearn module. Let's now see how to do predictions in Python using sklearn. So some super exciting stuff is waiting for you in the next few lectures. As always, it's a pleasure to teach you. Thank you so much for watching and have a great time. Welcome back. We are now done with the majority of the typical data transformation steps using pandas and scikit-learn, and now let's actually build some model. Now here I have built a model using Classic Studio and I have used this default dataset that we saw earlier. It has 1600 records and 16 columns. Then in this step, we select all the columns except the ID because it does not have any impact on the predictions. Next, we are cleaning the missing data for the numerical columns using their mean. And similarly, we do that for the categorical or string variables using mode. Then we normalize the data using min-max normalizer, split it in a ratio of 70-30, and then bring in the logistic regression model, train it with the defaults next month as the predicted column. And finally, score and evaluate it in these final steps. You know these steps. I have also run this, and now let me visualize the evaluate model and see the output. Now, this being a web-based interface, we will surely have some nice graphical presentation, and it will always look a little better. So if you scroll down, you will see this confusion matrix with these values of true and false positives and negatives. We also have this accuracy score of 0.775 or 77.5%. It's not a great accuracy, but this dataset is not full, and we are simply learning how to do these things. So I won't be too much concerned about the accuracy for now. And now let's go ahead and do the exact same steps in the Python environment and see the result. Here I am, and to save some time, I have done all the steps that we have already learned. Now please bear with me as I quickly recap and compare the steps in AzureML with Python. So we import pandas and read the file here. Then similar to the select columns in AzureML, we can achieve the same by simply dropping the ID column. Then here I am simply storing the null values. There is no need for this line in Classic. We can do that by simply visualizing the data here. Okay. Then we replace the string or object types using mode and the numerical ones with the respective mean, which is again same as these two steps that we did here. Then we are creating the dummy variables for all the categorical types. Now this step is not required in AzureML Studio because it implicitly takes care of it. So this is a bit additional step here. We then have the exact same step of normalizing the data using min-max scaler. And finally, we are creating these X and Y datasets and also splitting them in the train and test. This is same as using the split data module. Only difference here is we do not create the separate X and Y in case of Studio or Designer. That is already taken care of while training the model when we select the predictor column. And now let's go ahead and code for the logistic regression using Python. Welcome back. So for the logistic regression model, we simply need to import the class of logistic regression from sklearn. So that will be from sklearn dot linear underscore model. And this is the sklearn module from where we can import various model classes, including the logistic regression. And then import logistic regression as one word with L and R capital. And let's now create the object of it as LR equals to the class of logistic regression with two parentheses. Alright, and let me now keep the cursor on this class and hit Ctrl+I to see the help for it. Now, the parameters required are more or less same as the logistic regression seen in AzureML. We had the optimization tolerance, which is same as this TOL parameter. Then the L1 and L2 weight that we used to specify are nothing but these values of penalty and C. So, as we did with the logistic regression in AzureML, I'm going to leave the sklearn class at its default values. And let's simply go ahead and learn how to train it. Then how to get predictions as well as the confusion matrix and the accuracy score. So to train this object of logistic regression is pretty simple. All we need to do is type lr.fit and in parentheses provide the training datasets of X and Y. So that will be X underscore train, comma, Y underscore train. That's it. So loosely speaking, this method of fit will fit the data to the logistic regression formula and derive various coefficients and constants of that formula, which is nothing but training the algorithm. And this is very similar to the train model module. Here, we would bring in the object of the model and then connect the training data to train the model. Alright? And once we have trained it, we can use another method called predict to get the predictions. So let's store the predictions in a variable called y underscore predict equals to, and this trained object of lr dot, and the method is also known as predict, followed by parentheses and provide the X underscore test inside them. So this will now take the X underscore test as the input and provide the predicted values of Y in Y predict. Now once again to compare it, this is very similar to our score model module, where we used to get these scored labels and scored probabilities. Here we are only getting the scored labels in Y underscore predict. To get the scored probabilities, we need to use another method, and let me store those probabilities in a variable called Y underscore prob equals to the object of LR dot predict underscore prob A with two parentheses. And we need to provide the test dataset of x underscore test inside these parentheses. Great. So now let me select all these lines and hit Ctrl plus Enter to execute them. There you go. And let me now open the y underscore predict. And you will simply see these predicted values of zeros and ones. So in comparison to the studio, these are nothing but the scored labels. And now let me open the y prob. And here you will see the probabilities of the scored labels. Let me align it a bit. So what you have here in this column with index 0 is nothing but the probability of 0 or no default. And naturally, this will be the probability of default or yes. Let me scroll down a bit and show one such record where there is going to be a default. And there we have it. And let's go to the same index for this row over here. And there you go. This one has a probability of default of more than 50%. And that is why our algorithm has predicted it as a yes. But we may not need these two probabilities. Ultimately, their sum is going to be 1. And even if we know one of them, that is good enough. So, when we see this probability of less than 50%, we would know the predicted value or the scored label will be a 0. And it will be a 1 when it is higher than 50%. Alright? So, I am simply going to select this second column from this array. So, let me close these first. And to get the second column, I'm simply going to add a square bracket and then a colon, comma, and just 1 for the second index. This should take care of selecting the scored probabilities. And now let's take care of the last module of evaluate model and get the accuracy and confusion matrix for this model. For that, we need to import another module called confusion matrix from sklearn. So that will be from sklearn dot matrix import confusion underscore matrix. Okay, and now let's get the confusion matrix in a variable called cm equals to and then this function of confusion underscore matrix. And within the parentheses, we need to provide the actual and predicted values of the test data. So that means the first actual y, which is nothing but the y underscore test. Then a comma, and then the predicted y, which is in this variable of y underscore predict. That's it. And finally, let's get the accuracy or the score in a variable called score equals to, and we can get the score from the logistic regression method. So first, the object name of LR dot and the method of score for getting the accuracy of the model and two parentheses. Now, this score method expects the actual x and y values as parameters. So then provide x underscore test, comma y underscore test inside these parentheses. Great. And now let me execute these lines and then open the confusion matrix. And there you go. The values are more or less same. We had 359 true negatives in case of Studio, whereas here we have 362. The algorithm is same in both the cases. It's just that the way training and test dataset is prepared, as well as some default values of the parameters that make these predictions a little different. Also, let me compare the accuracy. And as you can see, the accuracy does not have a huge difference. It's just few digits after the decimal point in percentage. So essentially, both performed more or less same. Great. And with that, we have come to the end of this lecture where we compared and built the model using Studio as well as the Python program. And now I'm sure you can build any model in Python that we have seen in the Studio. All you need to do is simply go to the scikit-learn and click on the type of algorithm that you're looking for. And they're all defined as different classes. And their implementation is pretty much same, which is first you import the class from the required module, then you create an object, and if you want to change the parameter, you can specify that while creating the object. Then the next step of training is nothing but fitting the training data to this object. Then once it is trained, you will then get the predictions from this trained model. And finally, you can get the score or any other metric in the last step. Some of the names of these methods could be slightly different, but the documentation is pretty much clear with the example. So you shouldn't face any problem there. But in case you do, please drop me a message or ask in Q&A and I will be more than happy to help you. Great. And once again, congratulations for learning how to do data processing using pandas as well as how to build the models using Python and sklearn. And if you want, you can now proceed to learn the AzureML SDK. As always, it's a pleasure to teach you. Thanks for watching. Hello and welcome. And now that we have finished the full machine learning workflow using Designer, let's see how we can achieve that using the AzureML SDK. Once again, please keep this architectural diagram in your mind. This is like a Bible. So let's see AzureML SDK in the context of this architecture. The AzureML SDK allows us to manage the cloud resources of AzureML in our local Python environment. So far, we used a visual editor of Studio and Designer, using which we could create a workspace, data store, datasets, and all the other assets, as well as the compute resources. But with the help of this SDK, we would be able to do that much faster in our Python code. We can even train machine learning models on our local machines without worrying about the environment. This is usually one of the biggest issues while deploying the model. But the Azure ML SDK solves it by creating a local environment using Docker, which mirrors the final production environment. And of course, it is available across all the Python development tools as well as notebooks. Now, one thing that you have to understand is each of these assets are designed as classes within the Azure ML SDK. So you will have a class for workspace, environment, dataset, experiment, pipeline, and so on. They have all the specifications required to create each of these resources. And when we want to create them on cloud, we simply need to create an instance or the object of these classes. Alright? But this could all sound very theoretical. So let's see how to install it and then start creating these resources. It will make more sense then. So for that, simply go to your Anaconda prompt from your search bar if you are using Windows, or just open a new terminal with Anaconda prompt running on it. Then, as we do with any other Python package installation, simply type pip install Azure ML SDK and hit enter. Make sure you are connected to the internet, and it will start collecting and downloading all the packages of Azure ML SDK. Give it some time, and depending upon your speed, it could take a few seconds to few minutes. And finally, you will see this message that it is installing the packages. And once it is done, simply open a new program and try importing azureml.core. If it executes successfully, that means you have installed it correctly. And now, before we start working, allow me to quickly summarize the steps that we are going to take. So first, we will create a workspace using the workspace class. Then while creating this, once again, Azure will take care of the dependencies, or I would say it will automatically create these dependencies as part of workspace creation. Then we can bring in the data by creating the data store as well as the datasets. This is then followed by choosing the compute resource. And for now, we are going to use the local machine as the compute resource. And then finally, we can create our assets one by one. And for that, there is a sequence as well. But let's see those when we actually do that. So let's go to the Python environment and start creating our first workspace using Azure ML SDK. I am super excited for the next lecture. And thank you so much for watching this one. Have a great time. Welcome back, and in this lecture, we are going to learn how to create an Azure ML workspace in the simplest possible manner using Azure ML SDK in Python. So if you want to do it along with me, you are more than welcome. And as this is the first hands-on lecture of Azure ML SDK, and we are going to create the most important element of Azure ML, I'm going to go a bit slow in this lecture. So let's get started. So the first thing is to import the workspace class, and for that, we need to type from azureml.core import workspace with capital W. Remember, it's a class, and that's why it begins with a capital letter. Select this line and hit Ctrl plus Enter or F9 to run it. If the Azure ML SDK is properly installed, you should not face any problem in importing this class. But when you do it for the first time, it may take a few seconds to load it. Great. Now, in case you are using Spider and you don't see the workspace class the way I see it here, then it is very simple to view it. Simply click on these three lines of menu and uncheck this option of exclude callables and modules. If you have it checked, the classes, functions, and similar items are hidden. Anyway, so the next task is to create the workspace. And before we start coding it, let me double click on the workspace class to open it. And as you can see, it has opened this class definition right over here. And that's why I love this Spider tool for learning. We can get all the info right over here. So let me scroll to this create method here and click on it. And then you will see the documentation of this method in this box. Let me just expand this and adjust these frames so that we can see it better. And as you can read here, this method is used for creating the new workspace. Now, as part of creation, it requires a few parameters listed over here. Now, if you remember the lecture for creating the workspace using the Azure portal, these were the exact same parameters that we used to provide. So, of course, it requires a name for the workspace, then the subscription ID. You may have to copy this from the Azure portal. Then we used to provide the resource group name in which we need to create the workspace. And there was also an option to create a new resource group, and then the location. These were the minimum requirements that every workspace has to fulfill. I will share the link of the workspace class where you can see the full information of various parameters and what all it can do. So let me simply copy this sample code first and close this window. And now let's simply paste that in our Python program. Make sure your indentation is correct, otherwise it will give you this error of unexpected indentation. After that, let me change the name from this workspace to AzureML-SDK-WS01. Now, just for namesake, so that we know this is created using Azure ML SDK. Then you need to add your subscription ID here. And in case you don't know where to find it, well, from your Azure portal homepage, you can click on the subscriptions or even search for subscriptions in this search bar. After that, it will show you all the available subscriptions, and you can click on one using which you want to create the workspace. Then copy the subscription ID and then come back to the spider. And then simply paste this subscription ID inside these quotes. And now we need to provide the resource group in which this workspace resource will be created. So let me provide that as Azure ML SDK RG01. Alright. And then this parameter of create resource group simply tells Azure whether to create this resource group or it is an existing one. I'm going to leave it as true because this is the new resource group for me. And then we need to provide the location name or region in which we want to create this workspace. You may want to choose a region that is nearest to you for better speed and connectivity. Actually, it does not matter much except for certain services. So for now, I'm going to use the West US. And as you can see, the name provided over here is slightly different than the display name. Display names are with first letter capital and also has spaces in them. So a thumb rule is to remove the spaces from the display name and make everything in small case. I have also attached the most common location names in a text file as the resource for this lecture, and you can download it from there. Anyway, now this completes the basic and mandatory parameters required for the workspace creation. So before we run this code, make sure that you don't have a workspace already with this name, else it may give you an error. And if there is none, then simply select all and hit Ctrl plus Enter or F9 to execute these lines. And when you do it for the first time, it will ask you to authenticate your SDK session by opening a browser window and asking you to log in using your Azure credentials. And after that, it will very soon start by creating the resource group first. Then, as we have seen during the workspace creation using Azure portal, the overall workspace deployment takes around a minute or two. But you will start seeing various messages such as the resource group created, as well as all the dependencies or storage, key vault, etc. that are getting deployed along with their names. It will also show you how much time it took to deploy them. So for now, let me end this lecture here, and in the next one, let's verify our workspace creation as well as download the config file for future access to this workspace. As always, thank you so much for watching. Welcome back. Now everything is done and there is no error, means our workspace has been created successfully. But right now we are just guessing that. So let's verify it by going to the Azure portal. And now here you can click on all the resources. And there you go. We see this Azure ML SDK WS01 workspace created right over here. And you can also see all the dependencies such as the storage, key vault and the insights. You can click on this workspace resource to view the details. And there you have it. And here you will see this link of downloading the config file. So click on it and save it in a folder, preferably in the same working directory as other programs. Or you can create a folder called config and save it there. Then another way of doing the same thing programmatically is by using a write config method. Let me show that to you quickly. So just after creation, you can access this workspace object as ws dot and then use the method called write underscore config followed by 2 parentheses. Now this method will write the configuration file to some path that you will provide. For now, I'm going to provide the path as path equals to in quotes dot slash config. And when you execute it, you will see the config.json file inside the config folder, but inside a subfolder called .azureml. And we will require this config file whenever we want to access or connect to the workspace for other tasks such as creating the data store, datasets, and various other assets. Remember, workspace is the central authority or the top level resource within the Azure ML architecture. Great. So if you have been doing it along with me, congratulations on creating a new workspace using Azure ML SDK. So now you know how to create your workspace using the Azure portal as well as programmatically in Python using the Azure ML SDK. So congratulations once again, and I will see you soon in the next one where we will create the data store and then the dataset using Azure ML SDK. As always, it's a pleasure to teach you machine learning. Thanks for watching. Welcome back, and now that we have created the workspace, let's now create the data store. So let me create a new file for it. And I hope you remember the input required to create a data store. So you should have the storage account and some data uploaded to the blob container. We already have that, and I'm going to use the same storage account that we used earlier for Designer. We will also use the workspace that we have created in the previous lecture. So we will require the workspace class. So let's import it as from AzureML dot core import workspace. Then we also need a class called the data store to manage the data store resources from the AzureML SDK. So let's import that as well. So a comma after the workspace and type data store with a capital D. Great. And now let me first select this line and hit Ctrl plus Enter or F9 to execute it. It should not take much time usually. And once it is done executing, you should see this class of data store created in the Variable Explorer. So let me simply double click on it to open it. And here you will see the documentation of this class as well as various methods associated with this class. It does not have the usual create or delete methods, but it has these bunch of register methods. And if you have done the data store creation lecture from the studio, you would remember that we can create a data store using a blob container or data lake or file share, SQL tables, and so on. And these methods are just for that. And I think the name is self-explanatory of what they are for. Alright, so let me simply click on this method of register Azure blob container. And let me simply expand this and adjust the frames so that you can see the maximum of it. Okay, and as you know, the data store is an asset created inside the workspace. So similar to Studio, it needs the workspace name in which we want to create the data store. Then the name of the data store in alphanumeric and with only underscore. We also need to specify the storage account name as well as the container within it where the data is stored. And to access the storage account, we can either specify the SAS token or the account key. So it's the exact same thing as Studio, just that it will now be provided using the Python variables. Rest of the parameters are not mandatory, and because we are going to access the storage within the same subscription and without any virtual network, we should be okay, even if we specify just the mandatory parameters. So let me close this, and let's now go ahead and create the data store. So first thing is to access the workspace and create a workspace object that we can provide while creating the data store. So to access it, we can type ws equals to the class of workspace dot, and now we need to specify a method called from underscore config with two parentheses. So remember, in the previous lecture, we downloaded the config.json file and saved it in the config folder. Now, if the config file and the program is in the same folder or a directory, you don't have to worry about it. But if you have stored it in some other folder, then you have to provide the relative or the absolute path. Now, I have the config file in a subfolder called config, so I'm going to provide a relative path inside these brackets as path equals to, in quotes, dot, this dot makes it a relative path, slash config. That's it. And now select this line and execute it. It may take a few seconds as it needs to access the workspace from the Azure cloud. And it is obvious that you need to have a stable internet connection. And once it is finished, you will see this WS object created in the Variable Explorer. So now we can assign that while creating the data store. So let's do that. So I'm going to call the data store variable or the object variable as az underscore store equals to the class of data store with a capital D dot the method to register the blob container data store. And it goes by the same name as register underscore Azure underscore blob underscore container followed by two parentheses. And then we need to specify the workspace of the data store as workspace equals to, and now this WS workspace object that we created earlier, a comma, and hit enter to enter the next parameter on the new line. And then the data store name that we want to give as data store underscore name equals to, and I'm going to provide in quotes Azure underscore SDK underscore blob 01. That's it, another comma, and hit enter. And if you remember, now we need to provide the storage account name as account underscore name equals to, in quotes, provide the storage account name from where you want to fetch the data. So if you remember, we stored the loan data in Azure ML STB 01, comma, and in the next line, provide the container name as container underscore name equals to, in quotes, Azure ML STB 01 blob. Okay, and now we also need access keys for this storage account. So a comma, and in the next line, account underscore key equals to, and in quotes, paste the key for the storage account. And I'm sure you now know how to get the key from the Azure portal if you have done the previous lecture of creating the data store from the studio. Great, and now we are ready to create our data store. Everything looks good, so simply select all the lines and hit Ctrl plus Enter or F9 to execute them. It won't take too long to execute these lines. Within few seconds, the code should execute if everything is okay. And once it successfully runs it, you should see this az_store as an object created in the Variable Explorer. And it is now time to verify it from the Azure ML Studio. So let's go to the Azure portal and verify it. And then under all the resources, click on this workspace. And then launch the studio from this Launch Studio link. And once it is loaded in the browser, click on the data store right here at the bottom. And there you go. You can now see this data store created over here. You can now click on it and view the details of it. And there you will see the details such as a storage account, the container, and various other details. Great. And if you have been doing it along with me, congratulations on completing the hands-on for creating the data store using Azure ML SDK. And with that covered, let's now go ahead and create our dataset. But in the interest of time, please allow me to do that in the next lecture. Once again, thank you so much for watching. Welcome back. And I hope you remember this slide from the lecture on what is data store and the dataset. So basically, for creating the dataset, we need a storage account having data in one of these 7 data types. We already have that in Azure ML STB01. Then we need the workspace and the data store to create the dataset. And in the last couple of lectures, we have created that as well. Now, earlier, we created a dataset using the Azure ML Studio. And now, let's see how to create a dataset using Azure ML SDK. So what I have done here is imported the 3 classes of workspace, data store, and the dataset. We need the workspace and the data store to access their objects, and then the dataset class to create a dataset. I'm also creating the workspace object of WS using the config file. Alright, and now let's first access the data store as az_store equals to the class of data store dot, and then we need the method called get to get the data store information, or I will rather say to create a data store object over here. And as it's a method, we need 2 parentheses, and inside that, specify the workspace in which the data store is registered. So that will be WS, comma, and then the data store name that we want to access. So that will be Azure_SDK_blob01. That's it. So let me first select these lines and execute them to create these objects. It went well, and we have these 2 objects created over here. So now let's create our dataset. So first, we need to provide the path of the CSV file that we have stored in the storage account. So let me simply type CSV_paths equals to, and now remember, our dataset can be created using multiple CSV files which are stored in this data store. And that is why we need to specify that using the Python list. So a square bracket for the list, and then every element of this list will be treated as the path for one file. So we need to specify in normal parentheses the data store name as az_store, comma, and the relative path of the file in the container as, in quotes, loan space data / loan approval prediction. Great. Now, when we were adding the dataset using Studio, we didn't have to worry about the path and the name. It was easily displayed and we could access it. But here you have to make sure that the file path is the correct one, and it also follows the exact name. Also, it is case sensitive, so make sure of that as well. Now, let me explain what we just did. Here, the path of the file will always have the data store and then the relative location of the file, such as this folder name and the file name. And that is why it needs to be provided as a tuple inside the parenthesis. If you want to add another file, you simply need to repeat this tuple or this parenthesis term and then separate them by comma. Alright? So in summary, the path essentially is a list of tuples containing one or more combinations of data store and the file within that. Great. Next, let's create the dataset. So that will be loan_dataset equals to the class of the dataset dot, and now before we proceed, let's access the dataset class from the Variable Explorer and see its method. And this is why I love using the spider for learning or teaching, because you can access and see everything right over here in a very user-friendly manner. And once you're an expert, it actually does not matter which IDE or development tool you use. You can use Jupyter or whatever you want. Anyway, now here you will see a list of methods and child classes of the dataset. For creating a tabular dataset, we need to use this child class of tabular and its methods. So under tabular, you will see these 4 or 5 methods to create a dataset from different sources. Now, because our source file is a comma delimited file, we are going to use this method of from delimited files. Then, if you scroll down a bit and see the documentation of it, you will see various parameters that it requires. These are very similar to what we used to provide as the drop-down options or checkboxes when we created the dataset using the Studio. The minimum that we need is the path. So let me close this And let's now type after this dataset class a dot and then the child class of tabular with a capital T dot and the method of from underscore delimited underscore files. And inside the brackets, let's provide the path using the parameter as a path equals to and this CSV path that we created as a CSV underscore path. And if you are using some other delimiter or a separator, you can specify that as the separator parameter. For now, this is simply going to create the dataset from our CSV files. But it will not be registered within the workspace. For that, we need to add additional step of loan underscore dataset equals to loan underscore dataset once again dot and the method called register followed by 2 parentheses. And inside the parentheses, provide the workspace name where we want to register it as workspace equals to WS where we have our workspace object, comma, hit enter, and then the name of the dataset that we want to register it as. So that will be name equals to, and within quotes, let's call it loan applications using SDK. I'm adding this SDK everywhere just to identify them separately. Makes it simple. I'm also going to add one more parameter after a comma and on the new line as create underscore new underscore version equals to true with a capital T. It's a Boolean parameter. And this I'm doing just to make sure that if there is an existing dataset, this will get created as the new version of it. Then you can also add various other parameters such as description, overwrite, and so on. But for now, this is good enough to create and register our dataset. Great. And with all of that covered, let me select all the lines and execute them using Ctrl plus Enter or F9 in some of the cases, and then see what happens. Again, it could take some time and wait for a few seconds while it is creating and registering the dataset. Great. For me, it is done. Well, basically, I just paused the video while it was running. And now let's verify it by going to the studio. And then here, let me click on the dataset. And there you go. We have our dataset created and registered in our workspace. Click on it. And now you can see various details of it and can even explore the data if you want to. So congratulations for learning how to create a dataset using Azure ML SDK. I hope you are enjoying learning Azure ML SDK and creating these assets programmatically as much as I enjoyed creating these videos. Once again, thank you so much for joining me here, and as always, it's a pleasure to teach you. Have fun! Welcome back, and we have achieved some really good amount of work by now. We have created the workspace, data store, as well as the dataset in the Azure ML Cloud. And now let's see how we can access and list them using Azure ML SDK. We have already seen how to access the workspace using the config.json file using the workspace.fromConfig method. We also saw how to access the individual data store using the workspace object and then the data store name. Now let's see how we can list all the workspaces within a subscription. For that, let me declare a variable as ws underscore list equals to and then the class of workspace dot and the method to list all the workspaces is list. Then a set of parentheses, and inside that we need to specify the subscription ID as subscription underscore ID equals to and copy and paste your subscription ID. Now this is the minimum that is required to get all the workspaces. But in case you want to filter it for a particular resource group, you can specify that as well. So you can mention after a comma resource underscore group equals to and then the resource group name within the parentheses. But for now, I'm going to delete this and let's simply access the workspaces for this subscription. Alright, so make sure you have imported these classes by executing this statement. And then select this statement with ws list and run that as well. It may take a few seconds, so wait until it finishes making connections and retrieving the information. It is done for me, and now when you access and open the ws underscore list from the variable explorer, you will see it as a dictionary. And the dictionary key is nothing but the workspace name. Great, at least we have the workspaces in some format. But if you want to convert that into a normal Python list and even print them if you require, all you need to do is type ws underscore list equals to list, the list function of Python, and within the parentheses, once again, ws underscore list. Execute it and you will see the list of workspaces in this variable. Now you can run a for loop on it and then print all the workspaces. Alright, so that covers how to access a workspace using config.json as well as listing all the workspaces using the workspace.list method. Nice. Next, let's see how to access the default data store from the workspace. Here, we accessed the data store using the workspace object and the data store name. But for accessing the default data store, we don't have to specify the name and other details. I hope you have not forgotten what is a default data store. Well, it's the data store created for the default storage account where the workspace stores all the metadata. Okay? So first, let me declare a variable as az underscore default underscore store. And it is equal to, and now instead of the data store class, we can use the workspace object as ws dot and then the method to get the default data store, and it goes by the same name. And that is get underscore default underscore data store and the two parentheses. That's it. And if you execute this, it will create an object of default data store. And we can then use it to store the files or move the data to the default storage account. Great. Now, it is possible that over a period of time, you or your organization may create multiple data stores, and you may not remember the exact name of all of them. So you may want to list them down first before accessing an individual data store. Well, it's not at all difficult. All you need to do is declare a list variable as store underscore list equals to list, and within the parentheses provide ws, which is where we have this workspace object, dot data stores. That's it. Remember, this is data stores, the plural form, and not just the data store. Select it and execute it. It may take a few seconds. And after execution, when you open this list, you will see a list of data stores, including the default ones. Great. Next, let's see how we can get a single dataset as well as the list of all datasets in a workspace. For that, first let me declare a variable as az underscore dataset equals to, and we are going to collect the dataset object in this variable. So it is followed by the class of dataset dot, and the method to get an individual dataset is get underscore by underscore name, followed by a set of parentheses. And now we need to identify the dataset by workspace and the dataset name. So that will be ws, comma, and within quotes the name of the dataset as loan applications using SDK. That's it. And when we execute this line, you will see this AzureML dataset created as az underscore dataset. And then we can access all its methods as well as load the data for further processing in this program. It's not that difficult once you understand it. But remember, this dataset is created as an object, and if we want to access the data or manipulate the data, we will have to use its methods. And we will see that surely in the upcoming lectures. Alright? But there could be another problem. You may not always know the exact name of the dataset, and you may want to list them first and get their names before accessing them. Well, that can be done pretty easily, but its syntax is slightly different compared to this data store list. And just in case you are thinking it will be just ws.datasets similar to ws.datastores, well, actually no. So first, let me declare the list as ds underscore list equals to, and then make it a list by typecasting it as a list. And within two parentheses, we now need to access the dataset list from the workspace. So that will be ws dot datasets dot keys and two parentheses again. So when you execute this statement, this method of keys will return the dataset names in this ds underscore list. As usual, it may take a few seconds. And once you have that list, you can run a for loop as for items in ds underscore list and hit enter, and then print items in parentheses. So when you execute it, it will print all the datasets accessed in this list. Or you can even access it by viewing this list from the variable explorer. Great. So in the previous few lectures, we created the workspace, data store, as well as the datasets. And today we saw how to access them individually using their names and paths, as well as how to list them in a Python program. Alright. And with that, we have come to the end of this lecture. And let's now see how we can do data processing, or I would say how to upload the data or download the data in a data frame using various methods in AzureML SDK. Once again, thanks for joining me in this lecture and have a great time. Welcome back, and today let's see how we can access the data in and out of the AzureML workspace as well as the storage account. We know we need to use the data store to access the actual storage from the AzureML workspace. We have also seen that when we were working with the designer. So by default, the data that gets created during these steps, such as select columns or clean missing data or any such step, is stored in the default data store. And we can override that by going to the output settings for that step and then specifying the data store. And now let's see how we can do the same thing by using AzureML SDK. So let's go to the Python environment and see that. So here we are, and I have already coded these lines to import the classes for workspace, data store, and the dataset. And here we access the workspace from the config.json file, access the data store that we created, and then the default one as well, and finally the dataset of loan applications. Great. And now we are all set to start moving the data in and out of the Azure cloud. So before we proceed, let me select these lines and execute them. It may take a few seconds. So I'm going to let it run in the background. And now let's talk about the data and the pandas. So typically when we are dealing with the data in Python environment, we know we can use various pandas functions and methods to do the data processing. And for that to happen, we need to load the data in a pandas data frame. So let's see how we can load this Azure ML dataset into a data frame. For that, let me declare a data frame as df equals to, and now we use this object of az underscore dataset followed by a dot. And the method to load the dataset to data frame is very simply called as to underscore pandas underscore data frame followed by two parentheses. That's it. Isn't it simple? So select this line and execute it and let it run for a few seconds. And now when you go to the variable explorer, you will see this variable of df as a type data frame created over here. Let me double click on it. And there you go. We have the data frame loaded with the data from the cloud dataset. The column names are also very much in place. Great. And if you want, you can now proceed working on this locally. I mean on our local computer. And if required, you can use the pandas methods to even save them locally. Great. And now similar to loading a data frame with an Azure ML dataset, there could be a requirement to upload the data from the data frame to the Azure ML workspace as a dataset. And now let's see that. So for that, let me use the same data frame of df, but just to show the difference, I'm going to select a few columns from it as df underscore sub equals to df, and within the square brackets, specify the column names in quotes within two square brackets. So just for testing purpose, let me select married in quotes, comma, gender in quotes, and comma again. And let's say we also select the loan underscore status. Make sure the column names are correct within the quotes, and also any underscore is missing or not, or maybe even the case sensitive nature of it. Otherwise, it may give you an error. Great. And now to upload and register it as an Azure ML dataset, let me type az underscore ds underscore from underscore df, just to give some meaningful name. That is a dataset from data frame equals to, and then we need to use the class of dataset with a capital D, another dot, then the subclass of tabular with a capital T of course, followed by the method name of register underscore pandas underscore data frame. So as you can see, it has very specific method names to do certain tasks. And I'm sure it won't be difficult to remember them as well. Then inside the parentheses, let's provide some basic parameters such as data frame equals to, and then the name of the data frame, which is df underscore sub, from where it is going to pick up the data. Comma, and then in the next line, let's provide the data store through which we are going to store it. Remember, ultimately the data will be stored in the storage account, but we can talk to it only through the data store if we are using the workspace to upload it. So then the parameter for that is called as target equals to the data store object name from this program as az underscore store, comma, and finally we need to give some name to this dataset. So in the next line, let's provide it as name equals to, within quotes, let's call it loan dataset from data frame. That's it. And now you can select these lines and hit Ctrl plus Enter or F9 to execute them. And as usual, it will take some time to make the connection, upload the data, and finally register it. So give it some time and it should be done. It has run successfully, so let's now verify it by going to the Azure ML workspace. So once you are in the studio, click on the datasets. And there you go. We have the loan dataset from the data frame created over here. Click on it to view the data. So we have the details over here, and let's also verify the column names by clicking on Explore. And there you go. We have the exact same columns as we extracted from the data frame. Great. And that verifies creation of this dataset from the data frame. So in this lecture, we learned how to download the data to a data frame from the Azure ML workspace, as well as the opposite of uploading the data and registering a dataset from a data frame. Now, we just have a couple of small lectures after this on data IO operations, and after that, we will see how to create a data processing as well as model training scripts using Azure ML SDK. But remember, these are very important activities as majority of the time, we are dealing in only data processing. So hang in there in case your hands are itching for some model training stuff. As always, thank you so much for joining me here and enjoy your time. Hello and welcome. Now, this is the last lecture before we start running an experiment in Azure ML Workspace using the SDK. I just want to show you how to upload a local file or a local directory directly to the storage account using the data store. Also, I have created these workspace data store and dataset objects already in this program. You may always need them in almost every program when we are dealing with the Azure ML Workspace. So first of all, select these lines and run them. It can run in the background and it can get these objects while we can continue coding for the file upload. Alright, so to upload a file, we simply need to access a method of the data store object. So let me type the name of the object that we have access to as az_store dot upload_files, followed by two parentheses. And now we can specify the names of the files using a parameter called files. That is simple. And now we need to provide the names of the files along with their relative path in a list. Basically, we can provide more than one file. So let this be equal to files_list. And let's create this list just before this upload files as files_list equals to 2 square brackets. And let's now provide the path of the files as a string. So I have already kept two files called test and test1.csv in this folder of data. So let's provide the path to these files in our files_list. So the first one will be in quotes .data/test.csv, a comma after the quotes, and in another quotes ./data/test1.csv. Alright, you can specify many other files if you want to. For now, let's upload these two files. So come back to the upload files method and a comma after this files_list. And now in the next line, let's provide the target path where we want to store these files. And as you know, we have the loan data folder in the storage account of this data store. So let me provide that first. And the parameter for that is target_path equals to, and once again in quotes, loan data slash, and that's it. So all the files will be stored over here. Next, we need to provide the relative path of these files when we are picking them up. So as you can see, the relative path is the ./data/. So provide that in the next parameter called relative_root equals to, and in quotes, ./data/. That's it. So this will provide the relative root when we are uploading the multiple files. And I have seen that if this is not provided, it is possible that you may get some errors that it could not resolve the relative path. Okay, and then the last thing is to specify whether we want to override these files if they exist. For now, I'm going to override them. So for that, another comma, and in the next line, overwrite equals to true with capital T. And now we are ready to upload these files to the storage account using this data store. So simply select the list as well as these lines and hit Ctrl+ Enter or F9 to execute it. You will start seeing this message that it has detected the two files and it will start uploading it. It shouldn't take much time as the files are pretty small in size. And there you go. And let's now verify it by going to the Azure portal storage and see whether it has been uploaded correctly or not. So here I am in our Azure ML STB01 and this is where our data store is pointing to. So come down a bit and click on containers. Then click on this blob container. And let's see what we have got inside this loan data folder. And there you go. It has successfully uploaded the test and test1 files. So once again, congratulations on learning how to manage the data store for uploading the files. And now let's go back to our program and see how we can upload an entire directory or a folder to the storage account. It's not that difficult. It is pretty simple. And all we need to do is access another method of the data store object. So that will be az_store.upload. So this method of upload will simply upload the entire folder. So let's give some basic parameters required by this inside the parenthesis as src_dir or the source directory equals to, in quotes, let's give the same directory of data as ./data. That's it for the path. And then we need to provide the target path as a comma. And in the next line, target_path equals to, and simply provide the folder name where you want to upload this directory. So I'm simply going to use the same folder that we used earlier. So in quotes, loan data. And let's also create a data folder inside this loan data as /data. So now this folder of data will be uploaded as data to this loan data folder. All right. Then complete the quotes, hit enter after a comma, and now let's also overwrite it in case it exists. So that will be overwrite equals to true. That's all that we need to do. And now when you select and execute it, you will see all the files getting uploaded one by one. So while it is uploading, let's go to the Azure portal and see what is happening there. So here I am in the loan data folder, and now let me refresh it. And there you go. We have this new folder called data uploaded to this loan data folder. And let me click on it. Wow, all the files from the data folder on my machine are now uploaded to this data storage account. And we achieved that using the Azure ML data store that was pointing to this blob container. Great. So once again, congratulations for learning how to upload an entire directory or the folder to the storage account using the data store. I have attached this template as a resource to this lecture, and you are free to use it for your work. So here we have seen the two methods of the data store object, one for uploading the files or multiple files, and one for uploading the entire data or entire folder. Great. And now that brings us to the end of this lecture. And in the next one, let's now run a small data processing experiment in the Azure ML workspace. I am super excited for that, and I hope you have enjoyed the Azure ML SDK so far. Once again, thank you so much for joining me here. Welcome back. I hope you are excited to see how we can interact with the workspace and run some simple experiments. And you are going to see this architectural diagram hundreds of times in this course. After we are done with the course and you know how every piece of this puzzle fit together, you would know it like the back of your hand. So let me change a few things here and remove the complexity a bit. So let me get rid of this compute clusters and the compute instances. Let me also remove the model and endpoints for now. And let's also remove the environments and pipelines. And now we are left with just these four things. So we have already created the workspace. The dependencies were also created as part of it. The data store and the datasets are also with us. And now I want you to visualize this diagram slightly differently. Earlier, when we created and ran the experiments using Designer, it was on a compute cluster, but here we are using the local machine, and that will now be our compute target. We have seen how to get the data to the local machine via the data store. And now we want to log the results to the workspace. Now, this is different than simply uploading the data. What we are talking about is a program run on the local machine and then logging specific information in the workspace. And that's where the experiments come into picture. So basically, we need to create the instance of the experiment class and then create a program run as part of that experiment. This experiment will run on the local machine by using certain methods, and then it will be able to talk to the workspace. I hope that is clear so far. So let's go ahead and see how we can run an Azure ML experiment on the local machine and log the run data to the workspace. Thanks for watching. Welcome back. And now let's see how we can create an experiment, start the logging process, as well as complete the experiment run. As you can see, I have already copied and pasted these standard lines of importing the workspace, data store, and the dataset, as well as accessing them, or you can say creating the object for them. And now, to create an experiment, we need to import another class that goes by the same name as experiment. So after this dataset class, type comma followed by experiment with capital E. Okay, and then to create an experiment, we can simply use this class and then create an object out of it. So let me come down a bit and declare a variable of this object as experiment in all small cases equals to the class of experiment followed by two parentheses. And now we need to provide where we are going to create this experiment, which means the workspace details. So that will be workspace equals to and this WS object. And then let's also provide the name to this experiment as name equals to, in quotes, let's call it loan-sdk-exp01. That's it. And now this statement will create an experiment if it does not exist. And if it does, it will simply get the details of the existing experiment and create an object out of it. And this object we can then use in the subsequent execution. Alright, so for now, let me go to the Azure ML Studio as I want to show you something. And then inside the studio, simply click on experiments link under the assets. And as you can see, we don't have any experiments here. I just wanted to show you how things progress as we execute every line in the program. So let's go back to the spider. And now let me select all the lines and execute them. This will first access the workspace and other assets, and finally it will create an experiment for us. So it may take some time. So while it is running, let me go back to the Azure ML Studio and see whether our experiment has been created or not. So now let me refresh this page and very soon you will see the new experiment created over here. So if you have been doing it along with me, congratulations on creating your first experiment using Azure ML SDK. Great. But this column of latest run as well as the last submitted is blank right now. And that is because we have only created it. We didn't submit any run yet. So let's go back to the spider and see how to run it. So to run it, all we need to do is create a new object, and let me call it new_run equals to this object of experiment dot, and the method to start a new run is also known as start_logging with 2 parentheses. Now there are multiple ways that a new run can be started on the Azure ML workspace, and start_logging is just one of them. Okay, and now let me select and execute it. And if you are doing it for the first time, it may show you few warnings that the connection pool is full and it is discarding the connection or something like that. Just ignore it for now and go to the Azure ML Studio, hit the refresh button, and then you will see this column of latest run has 1 over here. And we also have the last submitted time. That means the experiment has started. So click on this experiment name, and you will see this run 1 is under the status of running. And running means it's still under progress. Completed here simply means completed successfully without any error. Failed means something went wrong and it gave an exception, and others are simply those runs which we have cancelled. Alright? So for now, let me hit the refresh button again, and you will see it under the same status as running. So what is happening here? Well, let's go back to the spider and I will explain what's going on. So as you can see, we didn't run a single line of code after this new run. We have simply started the run by executing this start logging method. But something that we started has to be stopped or completed, because this start_logging is a synchronous way of creating an experiment. And that's why we need to complete it. And by synchronous, I mean it keeps the connection alive. And the method for completing it goes by the same name as complete. So let me type new_run dot complete with 2 parentheses. Select and execute it. And now let's go to the studio and see the status of this run. Let me refresh it again. And there you go. Now our run is marked as completed. And the duration is also updated. So if you click on this run 1, you will be able to see few basic details under this tab. But honestly, there won't be any data, any metric, or any output for this, because this was just a blank run. But for now, I hope you can see where we are going. If this start_logging starts the run and the complete method ends it, that means if we need to interact with this experiment run, we have to add that code in between these 2 lines. So let's add few lines of code and log it as part of the new run. But in the interest of time, please allow me to do that in the next lecture. Thanks for watching. Welcome back. And now that we know how to start and complete the run of an experiment, let's see how we can log values to it. So for that, I have created these 3 blocks. In the first one, we are simply importing the classes, accessing the assets, as well as start our experiment run. Then the second block is what I call do your stuff here. So any data processing or any model training or anything that you want to do, you can do here. And the third one is of course the final part of logging the metrics and then completing the run. Majority of the time, it will work fine if you follow a discipline of not overwriting the metrics variables. So for now, let's do our stuff. So let's first load this data to a pandas data frame. So that will be, as we know, df equals to az_dataset dot to under pandas under data frame with 2 parentheses. I'm deliberately doing these things and not copying from other programs because Microsoft may ask you to fill in the blanks or choose from various options, and even a live experiment where you may have to code it. They keep changing the format every now and then, so it's better to get some hands-on. So select this line and execute it. It should go fine, but I'm not going to wait for it. Next, let's count the total number of observations as total_observations equals to, and that is provided by the built-in Python function as len and df inside the parentheses. Next, let's also get all the missing values from this dataset. And the syntax for that is the data frame of df dot is null and 2 parentheses dot sum and the parentheses again. Now, as you would know, this is null method simply checks if the value in a particular column is null or not. And then it will mark it as true or false. So it will return true if the value is null or missing. Then this sum method will simply do the sum of all the true values. So we will basically get a count of missing values per column. So let me select and execute these lines. And there you go. We have a count of all the missing values of every column. But this is of no use because it is simply printing it on the console. So let's collect it in a variable as null df equals to this entire statement. Select and execute it, and you will see a pandas series created in your variable explorer. Open it, and the column names will be the index of it as well as the values. Great. So for now, let's say this run has just this much data processing. So you start the run, do the data processing, and then complete it. But we also want to send these two things of total observations as well as the null value count to the workspace. Or should I say, we want to log them to the workspace. So let me just come down a bit, and under this log metric block, let's first log the total observations as new underscore run dot, and the method to log a metric is called as log. Very nice. And then inside the parenthesis, it expects the metric's name and the value. So let me type inside the quotes total space observations as the name of the metric, followed by a comma, and now provide the value which is stored in this variable of total underscore observations. So provide just that. Alright, and this is how we can log any value to the run metrics. For now, let me select all the lines and hit Ctrl plus Enter to execute them. It has started running, and once it is completed, we will go to the experiment run and see what has been logged. So let's just go there. And now refresh this page to see whether our run is completed or not. There you go, it has completed, and let's click on this latest run. And there we have it. Now we have this total observations logged as a metric of this run. Great, but this was just one value. And now let's also log the missing value counts to our run. This could very well be a requirement that whenever you do data processing, you have to provide these metrics and the stats. So let's go back to the spider and do just that. And now, because our missing data is inside the pandas series, we may have to run a loop and then log individual values. So for that, I'm going to type for and get the column names in our variable as columns in. And now to get the columns, we can use the attribute of this data frame df as df dot columns. So this will fetch the column names one by one. So colon and hit enter. And now let's log the missing value count inside this for loop as new underscore run dot log, and inside the parenthesis, the name of the metric, which is the column name for us. So that will be columns, comma, and then the missing count as value. Now this missing count value is stored in this null df series with the column names as its index. So we can access the values as null df, and inside the square brackets, the column names of columns. Great, and I hope you do not have any problem understanding this code. All we are doing is getting the column names using df.columns and getting the count of the null values from the null df. And then we are logging it one by one every time this for loop runs. Great. So now we are ready to run it. So select all the lines and hit Ctrl plus Enter or F9 to run it. Now this may take some time as it will first access the workspace and its assets and then start the run. So I'm going to pause the video and come back in the AzureML Studio. And if you have not refreshed it, refresh it now. And you will see that the run is now completed. And then you will be able to see all the details logged to our experiment run. So under this details tab, you will see a snapshot of these values. But if you want to do some preliminary analysis of this data, you can go to the metrics tab. And there you can analyze each of these metrics individually, either as a chart or as a table of values. Great. And with that, we have come to the end of this lecture. So in the last couple of lectures, we saw how to create as well as access the AzureML experiment from the workspace. Then we saw how to run an experiment by logging values, and finally we ran a couple of data processing steps and logged those values as well. Great, and that really sums up what we did today. And with that, please allow me to end this lecture here, and in the next few lectures, we will see how we can run a model training script locally and run it as an experiment in AzureML. As always, it's a pleasure to teach you Azure Machine Learning. Thank you so much for joining me here and have a great time. Welcome back. So in the last few lectures, we learned how to create an experiment, get the data using Azure Data Store, run it and log the metrics to AzureML workspace. This was all done on our local machine using the local configuration and local environment. But how do we know that the local environment is compatible with the production environment? Or in simple terms, the local environment is supposed to have the exact same packages and modules as the production. Also, it's not just about the same packages, even their versions need to be same to make sure that we don't run into some compatibility issues later on. Now, as you can see here, there are different versions of Python and various packages that we use for machine learning. There is a new version almost every month, maybe minor ones, but they surely bring in some uncertainty. Here I have only shown for Python language, pandas and scikit-learn. And if you want to use various other packages such as matplotlib, OpenCV or TensorFlow, then it becomes all the more difficult. In many cases, these packages resolve their dependencies, which means if it requires a higher version of some other package, it may just resolve it. And resolving simply means it may download and install the latest version. And that makes managing the same environment on different machines very, very difficult. And if different data scientists are working on one large experiment using their own local machines, it will be very difficult to maintain the exact same environment on all those machines. Now, this can create typical software development issues of non-compatible packages and environments to the desired production environment. And for that, Docker and its containers can help us create some environment on all the machines. I mean, the same environment. Some of you may have even worked on Docker, but it could be a bit tedious job for those who are not well versed with Docker and containers. And as a data scientist, you want to focus on data and algorithms and not system administrations. And that is where Azure Machine Learning Environment comes into the picture. Azure ML creates the environment for us with very few parameters, and it is user-friendly as well. So you can create your script using Python, and at the time of submitting it using a job, you can simply tell Azure ML that you need an environment that should have the packages that your script needs. And Azure ML achieves this by what is known as the script run config class. Or you can say the object of this class specifies an environment as well as run configuration for running a script in Azure ML. Alright, so in the next lecture, let's go ahead and see how we can create a customized environment for running the script. Many things will be absolutely clear when you will see an environment getting created on your machine, and it is going to load only those packages which are required for your script. So some exciting stuff is waiting for you in the next few lectures. So see you soon, and as always, thank you so much for joining me here. Have a great time. Welcome back, and now let's see how we can submit a script run to the Azure ML workspace, and also how to work with different environments. So I have already imported the workspace and experiment classes, and then I also accessed the workspace object using the config.json file using the from config method. Also save this file by the name 170 space submit job. And now let's straight away run an experiment in this workspace as new underscore experiment equals to the class of experiment followed by two parentheses. And next we need to specify the workspace name for this experiment. So that will be workspace equals to ws and a comma. And then the name of the experiment as name equals to, and let me call this as lone underscore script. Great. And next let's submit a new run for this experiment as new underscore run equals to the new underscore experiment dot, and the method to submit a new run is called as submit followed by two parentheses. That's pretty easy to remember. So to start a run in Azure ML workspace, we can either use start logging or this submit method. And if the requirement is simply to log the metrics, we can use start logging. But for submitting a script, we should ideally use the submit method. Now, before we start coding the parameters for this new run, let me open this experiment class. And let's go to the submit method. And as you can see, it says submit is an asynchronous call. So basically what it means is it will submit the experiment and then terminate the connection to the Azure ML platform. Also, it requires a parameter for configuration of this run. By configuration, we simply mean which compute target should be used for this run. Then what should be the environment as well as where to find those scripts that we want to run. So to specify the configuration for a script run, we use an object created using this class of script run config. Let me first close this and code it, and then it will be all clear. So now inside the two parentheses of this submit method, let me type config equals to script underscore config. And we don't have the script underscore config defined. So just before this, let's now define it as script underscore config equals to the class of script run config with SR and C capital with two parentheses, of course. But we have not defined it, and that's why it will give you this error of undefined name. So let me import it. So come up and a comma after the experiment class and then the class of script run config. Alright, and now the submit method needs to know which script to run. So let's first specify the directory or the folder where our script is saved. And the parameter name for that is source underscore directory equals to, and because I'm going to keep the script that we want to run in the same folder as this one, I'm simply going to specify a dot inside the quotes, then a comma, and in the next line we need to provide the name of the script from that folder as script equals to, and in quotes the name of the Python file. So I'm going to provide that as 180 space dash space script to run dot py. And by now you must have realized for this course I'm simply giving these numbers before the program names so that it will be easy for you to find them in a sequence. And I hope that helps. Great. And now let me quickly summarize what's going to happen. So this program of submit script will submit the script to run using this script config object to this experiment, or I would say lone script experiment, and in this new run. Alright, so I hope the hierarchy and the sequence is now clear. And now we are actually ready to submit this script. But remember, this script is simply a job that will submit some other script, and that script is specified in the run configuration. But we actually don't have a script to run. I mean, we didn't code it. We surely submitted this program to AzureML and even ran it. But now, when we submit a script from some other job or some other program, we need to make few changes to it. And what those changes will be, well, in the interest of time, please allow me to make those changes in the next lecture. See you soon, and thank you so much for watching. Have fun. Welcome back, and now let's see what changes are required in our earlier script so that we can submit it as part of an experiment run. So let me first select all these lines and copy them and open a new file, and then paste all these lines there. I don't want to directly update this already saved file, okay? And let's save this new one as 180 space dash space script to run dot py. Alright, and let's now see what changes we need to make to this script. So for now, I'm going to leave this import statement as it is, and then also leave this object creation as it is. Actually, we may or may not need all the classes and all the objects when we make these changes. But let's remove the objects only when we are certain that we don't need them, okay? Then we are creating or accessing the experiment here, and then creating a new run for that experiment. But if I go back to the job script, you will see that we are already submitting a run as part of this new experiment.submit. And now if we use the start underscore logging, it's going to create another new run. And we don't want to do that. We want to submit this script as part of the run created in this job. And that is why this statement with start logging method is not required. So let me delete that first. But then the question is, how does this script know in which experiment run it needs to be executed? Well, that's where we need to use another method of a new class called run. So let me first import that class, and let me write it in a new line as from AzureML dot core import run with capital R. And let me execute it so that we can see the documentation of it. And in case some of these things are not making some sense at this stage, just hang in there for a couple of minutes and it will be absolutely clear. It has run successfully, and let's open this class from the Variable Explorer. And as you can read, it is the base class for all the AzureML runs. And in that, the asynchronous runs, which means those which are submitted as part of the submit method. I'm sure by now you know that a single run is nothing but a single trial of an experiment as well. So every time we submit an experiment, we create a new run. We saw that in the previous lectures. And with the help of this run class, we can monitor that run or log values or even store the output. And that is something really interesting that we will see towards the end of this series of lectures. Then another thing that I want to show you for this class is its method called get_context. Scroll down and you will see it here. And this method is used to retrieve and access the current run. If you just read this, it may not make much sense. So let me explain that with some visualization to make it clear. We know the workspace has experiments and various other assets, and every experiment trial is an individual run. So from this local compute, when we submit this script or the job, it will create a new run. And let's say, hypothetically speaking, it is the run 1. Then, as part of this job, we are also submitting the training script. And as we discussed earlier, we don't want this training script to start a new run. Whatever it does, it has to do it within this particular trial or this run 1 only. And that is where this method of getContext helps us. So when we run this training script with a run.getContext statement, it will not start a new run, but it will be part of this run 1. So whether we log any metrics or do data input-output operations or whatever else that is allowed, everything will be considered as part of the run 1. Alright? I hope you now understand how the getContext method of this run class helps us in running this training script in the existing run. And with that covered, let's now go back to the spider and code for it. So that means now our new run will be new run or new underscore run equals to the class of run dot the method of get underscore context with 2 parentheses. That's it. And because we are going to get the run context, we don't need to access this experiment once again. So let me delete this experiment object creation as well. And now I'm going to keep this data frame of df as it is, as well as getting the total observations and the null values. Also, we don't have to make any changes to this log metrics block. And the same object of new run can take care of it. So in a sense, we only had to change the way we access the run. So we deleted accessing the experiment and creating a new run. And simply got the context of the actual run. And save this file once again, and with that we are now ready to run the job or the submit script program. So let's go to the 170 submit job program, and if you are doing this along with me, I suggest you first watch this one and the next couple of lectures before submitting this run. And the reason for that is you may want to observe certain changes that I'm going to show in the next lecture. So for now, let me select all the lines and hit Ctrl plus Enter. It has started running and it may take some time. So I'm going to end this lecture here, and let's see what happens to the script and the new run in the next lecture. As always, thank you so much for watching. Welcome back. And for me, this script has been submitted as well as finished running. And when you do it for the first time, it may take roughly 4 to 5 minutes to finish the run. And now please allow me to explain how this submit run progressed. So when we go to the experiments page, you will see this lone underscore script experiment created, and it shows one run as submitted. Then if you click on the lone underscore script, it will show you all the runs, which for now is just one. But the status here is in other category, and that is because our run is under the preparation stage. So what happens during this stage is it creates a new environment on the compute target. And that compute target is the local machine in this case. So if you go to the Anaconda Navigator and within that, click on this environment link, you will see an extra environment built over here. Now, it may not be visible immediately. You may have to wait until the preparation stage is completed, which may take anywhere between 5 to 10 minutes, depending upon your system configuration as well as the internet speed. So please wait until the status is changed to running. And then here you will be able to see various packages such as the AzureML core, Dockers, as well as the Python language installed in this environment. But by default, AzureML environment uses the more stable version of 3.6.2 for Python, whereas you may have a higher version of it on your local environment or the root. And as you can see, for my root or the base environment, I'm using the Python 3.7.6 version. Also, this AzureML environment will install only the basic packages and the most frequently used ones. So here I have 82 packages installed, whereas for my base or the root environment, I have got 372 packages. So I have got scikit-learn, matplotlib, MySQL, and various other packages installed in my root. But you will not find those in this AzureML environment. To use them, we may have to specify them separately. And that also means we are in full control of various softwares and packages required in production as well as the development environment. Alright, and now let's go back to the AzureML Studio and to the experiment run. And here, after you see the status as running, you will also see the script name as the name of the Python file that we provided. Then we have the logical name of the environment in which this script is running. It simply adds this experiment and this environment to the experiment name. If you click on it, you will see this cryptic name that starts with AzureML. And this is the same environment name that we saw in the Anaconda environment. Alright, and once it starts running very soon, and most probably within a minute or so, the status will change to finalizing and then completed. And after completion, you will see the duration for which it ran. So remember, the run 1 got created at 9:36 and was started at 9:41. So basically for around 5 minutes, it was in the preparing stage or preparation stage. And actual run took 1 minute 45 seconds to finish it. You will also see these metrics logged as part of this run. Great. So eventually nothing has changed as far as the output of both those scripts are concerned. Because here we didn't change anything except the first one uses the start logging and it ran independently, whereas the second one was run with this run.submit method and using a job. Great. You can also see how the environment preparation went by going to this output plus logs tab and then opening the control log file. So it first tried to fetch the environment and there it failed to do so. And because of that, it gave this message that the Conda environment is not found on the compute target. So then it went on creating it, and you will also see various packages that it downloaded and installed as part of it. That's just another way of looking at the preparation stage of our run. Okay. And now you may wonder, why do we need this? And what are the advantages of using this Azure ML environment? Well, it surely provides us the ability to track all the softwares and their dependencies. Then it also ensures that we can reproduce the environments on any machine and removes any environmental uncertainty. Then we can also reuse these environments. So in case you wonder whether it will produce these environments all the time, well, no. If we run this same script or some other script that requires an environment which is similar to this, then it will use the already existing one. And I'm going to show that to you in the next lecture. Then another biggest advantage is we don't require manual configuration of the environment on every machine. We can simply specify that as part of the script run config and then use it from any machine. Great. I hope that explains how to submit and run a script in an Azure ML workspace and customized environment. Let's now see what happens when we rerun this script, as well as how we can upload the data automatically and create an output folder in this run. And let's do that in the next lecture. As always, it's a pleasure to have you in the class. Thank you so much for watching. Welcome back, and today I'm going to rerun this script using the same job, but I have made some minor changes to it. So in this 180 script to run program, I have added these 2 lines, and they are pretty easy to understand. First, I'm creating this new df from the original data frame and selecting just these 4 columns from it. And then using the to_csv method, I'm writing this data frame to the outputs folder. So this method of to_csv will create a CSV file out of the data frame and then write it to this destination with this name. In this working directory, I have already created an outputs folder. And when we mention index equals to false, it will ignore the index values and write only these 4 columns. Then in this submit job script, I have added this 1 line at the end of the script. And as the name suggests, this method for wait for completion will simply not finish this script locally until the run is completed. So basically, you will see it running on this local console over here. Great. And now let me select all the lines from this submit job and execute them. You will now see it running over here, and it will not be done in a flash as long as the script is running. So let's go to the studio and see what's going on there. And as you can see, we have one script running over here. Click on it. And as you can see, the create and started time is same. And this time we don't see a delay in creation and the starting time. And the experiment name is the same as the previous one. So let me just click on it. And you will see the exact same name as the environment name over here. Well, I can't exactly remember it, but I'm pretty sure it started with these letters of DA3E97. So it surely appears to be the same environment. Let me close this and refresh it, and hopefully it will be completed. If not, simply wait for another minute or so and then refresh it again. There you go, it has now completed, and the duration is also more or less same as the previous one. The metrics are also logged. So you may wonder, what did these 2-3 lines that we added do? What was their effect? Well, let's go to the output plus logs. And there you see this extra folder of outputs. Expand it and click on this loan_trunk.csv file. And this was the one that we wrote to our local outputs directory. But now we see that file with the same column names over here. So basically, Azure ML has this built-in functionality that whatever we add to the outputs folder within the working directory will be uploaded to the output plus logs. And remember, this can be any file. You may write certain messages, you may create your own log file based on Python log function, but as long as you save it in the outputs folder, it will be uploaded to this outputs tab. Alright, and now let's see what this 60 control log file has. And as you must have noticed, this time it is much shorter compared to the previous run. So in this line, it first goes and runs a bat file called Conda environment checker. And then it found this existing environment that we created as part of the previous run. And that's why it didn't create a new one. Remember, during the previous run, it actually created an environment and then ran the script. And I hope now you understand how the loan trunk file got uploaded automatically to the output and also how it reused the existing Azure ML environment. Rest of the processing was exactly same as the previous ones, and because of that, we see various metrics getting logged and the script giving some output. Now, even this file of 160 did the same processing as 180, but this time, we learned how to submit the script using a job to an Azure ML environment, as well as how to upload an output file to the existing run. We also learned how to configure the environment using this script run config class. And let me tell you, we have covered a great deal of work by now. So in the next lecture, let's see what all things we have covered as far as the DP100 exam is concerned.
As always, thank you so much for watching.
Welcome back. So when we use Designer, we learned various exam objectives using Azure ML Designer. And in the last few lectures, we have learned a great deal of that using the Azure ML SDK as well. So we saw how to create a Azure ML workspace and within that, how to manage it as well as how to configure it. Then we also created the data store as well as the data sets. We are yet to learn how to configure the compute instances using the SDK. But once we are done with running the scripts, etc. on the local machine, we will go through that as well. Then we also learned how to run the training scripts using the Azure ML SDK. And within that, we have completed the 3 exam objectives of create and run an experiment, consume data from a data store, as well as consume a dataset using Azure ML SDK. We are still to complete creating an estimator, but very soon in this section, we will complete that as well. And by the way, that has been also removed as an exam objective as on 8th of December 2020. But we will still go ahead and learn it because I think that is a good thing to learn as far as Azure machine learning knowledge is concerned. Then we have also learned how to log metrics from an experiment run as well as how to upload, retrieve and view the experiment outputs. So as you can see, we have completed a great deal of work by now. And I hope you are feeling a bit more confident for your DP100 exam now. So let's now go ahead and build a real machine learning model and complete the rest of the exam objectives. As always, thank you so much for watching. Welcome back.